Good morning, ladies and gentlemen. I hope I'm audible to everyone watching online. It is my honor to be able to welcome everyone to our first official project competition, ENERGIOMEX 2021. Before I start, I would like to quickly convey the main motto for today's event. ENERGIOMEX is an open to all project competition where the students design, procure materials, and construct a project adhering to the HVAC&R industry within the given time frame. Let's give a little background on Ashrae. Ashrae, founded in 1894, is a global society advancing human well-being through sustainable enhancements for the built environment. The society and its members focus on building systems, energy efficiency, indoor air quality, refrigeration, and sustainability within the industry. Through research, standard writing, publishing, and continuing education, Ashrae shapes tomorrow's built future today. Our mission is to serve humanity by advancing the arts and sciences of heating, ventilation, air conditioning, and refrigeration, commonly known as HVAC&R, and their correlated fuels, and our vision is a healthy and sustainable built environment for all. I, Nafisa Shams, and my co-host, Sai Rohit, whom you will be seeing shortly, hosting on behalf of Ashrae Falcon Student Chapter Mahe Dubai. We would love to invite a few honorable dignitaries who joined regardless of their busy schedule. To begin with, we have Dr. S.V. Kota Reddy, who is a veteran academician and administrator with more than 30 years of teaching, research, and administrative experience. He joined VIT and he previously worked as the academic president at Manipal Academy of Higher Education Mahe Dubai campus. He is a member of Ashrae, American Society of Heating, Refrigeration, and Air Conditioning Engineers, and elected by Ashrae Falcon Chapter as the chair for students' activities from 2017 to 2020 in the UAE. Dr. Kota guided several research projects funded by Ashrae. He is a PhD examiner from IIT Bombay and many other prestigious universities in India. Now, I would like to request Dr. Kota to give few words of wisdom. Thank you.
Are you able to hear?
Yes, sir.
Yes, sir. Yes, sir. We can. Yes.
Yeah. Good morning, everyone. And on this occasion, I would like to request all the students to take the advantages of Ashrae membership. You have several benefits. If you are the member of Ashrae, you are eligible for many of the activities and many of the scholarships, and you can also apply for the project grant. You can get the project grant, and you can have the publications also at a reasonable price, and you will have very much discounted price. You will get the publications, and even if you are member, you will get Ashrae journal free of cost. Okay, Ashrae is not going to charge you anything. Every month you will receive a journal. Now the list is very big, and I request all the students to go through Ashrae website and then see there is a student zone, separate student zone is there in the Ashrae website. Please go through that Ashrae student zone and then see what are the benefits you are going to get. And there is one more important thing is that Ashrae design competition also is there. It is a worldwide competition. Then most of the mechanical engineering students know about Baha competition, and the same way the Ashrae design competition also happens. And actually most of the students don't know about this. But I'm telling you, this is a very big competition. Now please actually participate in Ashrae design competition. It is a worldwide competition. Most probably this year, I'm not sure how it is going to happen. Maybe it's a virtual competition may happen like what we are doing today. Now, therefore, dear students, I mean, it is your duty to, or your, I mean, you should take the advantage of this membership of Ashrae. And then, and you should inform your friends and then other students, your colleagues, such that they will also become members. And Ashrae is doing a lot of activities, but as educational institutions, as students, it is our obligation, our duty to take the advantage of them. I would like to admire the efforts of Professor Sampath Suranjan and then all the student members of Ashrae Mahe Dubai actually to take this lead.
Srijit actually is the president of Ashrae student branch and doing extremely good. Srijit, Sanal Kumar, then Parvati Anil Kumar, then Anthony Jose, then Vivian Vincent, then Ananda Dhar, then Nafisa Shams. A great effort by all these students, and I mean, definitely you will do many such activities, and I wish you all the very best. And the teams, definitely, whether you win or not, but participation is very important. Okay, I wish you all the very best. Thank you very much. Thank you so much.
Thank you, Dr. Kotaredi, for your wise and very motivational words. Next, we have Mr. Ade Awola. I would like to invite him for some wise words to share with us. Thank you.
Yeah, well, distinguished Ashrae members, distinguished Ashrae students, and some of our guests here. So it's a privilege to be here this morning to talk to you. The importance of Ashrae student membership cannot be overemphasized, as you've heard from the speaker, the past HESA chairs of Falcon chapters. I just have a few notes to add to what he has said, because he said so many things about the benefits of Ashrae to students. One of the greatest things that Ashrae has to offer students is that Ashrae is providing you with a platform of over 56,000 members to network across the globe. What does that mean to students? What that simply means is that students will be in a location and be able to network across the globe just by sitting in front of their computers, going to Ashrae websites and do a great networking. So one of the importance of this occasion today is that at Ashrae, with Student Activities Committee, where I chair, we're looking at the possibility of integrating some of programs like these that are very credible and progressive in nature. We're trying to see how we can integrate this kind of program to a regional and also at society level, where students in Dubai, students in the Middle East can network and give us the platform to expose themselves, into the larger network of Ashrae. So this is a very commendable event. And just recently, we set up a committee that calls Town Hall and Quiz Competition Committee, where a program like this will be taken further beyond the four corner walls of the Middle East alone. I may not know, but I share this program in our platform, and I think some of our members in other regions are joining me to watch this event, which is a very commendable, exercise. What I will say to all of you who are participating in this program is that you are not just exercising knowledge, but you are impacting on the global community by trying to demonstrate, some of the things you have learned, by by expanding the frontier of your knowledge, to bringing up some sort of research work to the recognition of the Ashrae community. And I must commend the Ashrae Falcon for supporting student branches such as yours and making this program a reality. Professor Surajan has been, a very robust thinker over the years, and I've been I've been studying based on some of my researches across RAL. And so it is not surprising that you have a program like this that will be presented on a platform where Ashrae leadership will come in and fetch out some talent. To the students that are participating in this program, what Ashrae offers you is a platform for you to showcase some of your talents, for you to showcase your brilliance, for you to demonstrate how intellectually built and rigorous you can work. And so today, as you present in this program, I want to assure you that people who are likely to be your prospective employer in future are watching and are looking out for how they can tap into the gift you have and give you the benefits of success. And this is one of the greatest things that Ashrae offers students. They give you a platform where you can exercise your knowledge, where you can integrate what you know, where you can also combine what you know with what is professionally expedient, where you have the idea of what is expected in the industry very quickly. So all I can say to you today is to wish you a very good luck in your presentations, as some of us, will sit down glued and listen, very distinctively to what you have to offer. There's so much that you can benefit from Ashrae, but it cannot be overemphasized that you have the benefit of sponsorship, benefits of grant, there's postgraduate scholarship that you can get if you're doing postgraduate program. And Ashrae can sponsor you to the tune of $10,000. And if you have paper that you can present at the winter conference, that will also give you another benefit of $1,500, and so on and so forth. But the most important thing for us is to make sure that when you come here as member of Ashrae, as student members of Ashrae, we do the best we can to make sure that your future is crystal clear to you. And so I will enjoy you to continue the great work that you're doing, and also make sure that you invite some of your friends in other allied disciplines, to come into Ashrae. Ashrae is not just for students in mechanical engineering alone. It's for students in architecture, students in other built environment, disciplines. So it is my pleasure to be here today to see how you're going to excite and make this a very interesting occasion for all of us. I thank you for this privilege, and I look forward to many more of such in future. Thank you.
Thank you for your wise and kind words to all of the students watching today. Next, I'd like to invite the Dean and Chairperson of School of Engineering and IT from Mahir Dubai campus, Dr. S.K. Pandey, to speak a few words.
Thank you, Mrinal. First of all, good morning to all of you, all the students, my colleague, faculty members, and our esteemed guest, Dr. S.V. Kotareddy, Vice Chancellor, VIT Amravati campus, Mr. Abe from Ashrae Falcon chapter. Thank you for spending time with us. I know that everybody is very busy, but thank you, sir. Thank you for finding some time and motivate our students. In Manipal, I think we are very active in students' activity. And in that also, if you ask me, Ashrae is one of the most active society. And it's fully driven by the students. So I'm really happy to see one more event. I think this is the second, third event that recently we have organized. So really it's a commendable job done by our students. And I have seen, because I'm here, so I can see the energy in the students, the projects, the way they involve. And definitely because of the pandemic, it is not possible to conduct the way we conducted in the past. But one good thing is that because of the pandemic, I think we are connected with so many people that may be not possible if we are organizing in the campus this activity. So I think it's a good opportunity also for all of us. 2 minutes I will just take, and definitely I know everybody is excited excited for the events, but one important message to all of you and professional society, I think become a part of the professional society and connected with the professional society is a very important things in your professional career. I have seen many advantage of this. I think it is not only just to develop the technical skills. Most important thing is basically to learn a lot of other skill sets like leadership skills, like how to manage. If you ask me, the project management skill that you learn through such events. Because if you are organizing this event, this is a big thing. This shows how to initiate something, how to plan something, how to execute something, and then definitely how to close something. So you see the kind of learning you have during this process, apart from your definitely projects that you are going to display or the idea that you are going to discuss with everyone. It's a great learning that's very difficult to, I think, get in a classroom environment. And that is only possible through such kind of activity through professional society. So please continue such good things, okay? And whatever supports you need from our side, I think definitely we are here. Ashrae is always very kind enough. I have seen the kind of support they have provided. And one very important person that is always behind the Ashrae, Dr. Kota Reddy, even though he's not here with us right now, but always is very much, actively involved in the Ashrae. Whatever he is busy, I know that his role and profile, but for Ashrae, always you find the time. So thank you, sir. I think still you are motivating, even you are not with us with the same energy, I can see. And for me, always it's easy. When it comes to the Ashrae, I'm very comfortable because I know there is a one guiding hand is there. So please, once again, thank you for your support and thank you for the Ashrae Falcon chapter support for all these activity, and especially the Sampath. Definitely Professor Sampath is very actively involved, and projects is always close to his heart. I know he's always involved in the project. He always involved with students in the project. So please, students, continue, take the advantage of such kind of platform. Those who join from outside, I think it's a good platform to interact to all of us. And I'm looking more such event in the future. So thank you once again, and looking forward for more such events in the future. Thank you.
Thank you.
Thank you, Dr. S.K. Pandey, for your wise and kind word to all of us. Now, I would like to invite Ms. Mrinal Kulkarni for a short prayer to start our event auspiciously. Thank you.
First of all, a warm welcome to all. The reason why I'm here is to share a message. We are in fact really lucky for being able to stay safe and be blessed in this current pandemic. All that you can see in an undesirable experience and situation being experienced by this world. Our lives too will be more or less the same or being more demanded by the personality features. But we have got the courage and determination, which we can help the people who need to survive in this current pandemic. Let us take a moment to thank all the experiences and the opportunities that are in front of us. Let us not forget and pray for the ones who are less fortunate, especially during this global crisis. I request you all to entail in a minute of silent prayer. Thank you for your patience. Now I would like to call Nafisa Shams to continue.
Now, we would like to officially start ENERGIOMEX Project Competition 2021. And it is our honor to have national as well as international universities participating in today's competition. ENERGIOMEX Project Competition 2021, a dream that our chapter saw a few years back. things didn't really go our way before reaching this day to finally organize this event. COVID played a spoil sport last year and tried to stop us, but we came back stronger. And today, this competition is not only limited to UAE, we got international universities participating as well. We are honored and thankful for your participation, and we're looking forward to see your projects. Let's run through the event before we dive into the competition. In today's event, the participating team should be able to explain the topic in details during the explanation. The participants are expected to maintain fluency. The participants are requested to speak within the time limit of 15 minutes to avoid negative marking. Working of the project must be displayed during the presentation, has to be a working model. To start off, we have Sai Rohit, who is currently present in Manipal, Dubai campus, where the in-campus projects are being displayed currently. We will start our competition with the in-campus projects first. Sai Rohit, please feel free to take over.
वो स्टार्ट हो गया Thank you, Nafisa, for that energetic beginning. Good morning and a very warm welcome to everyone into the Manipal Academy of Higher Education, Dubai campus. Right now, we are standing a few meters away from all the projects that are lined up for us this morning. So, before we get there, we'll get this checked. Temperature. Right, we're done. Let's go in. So, I met few participants this morning. Some look really confident, but some are scared. My responsibility here is to keep them comfortable so that they can present their projects at peace. Now, our first team, SYK, is ready behind those doors. So let's get in there first. All the participants have made a really great projects today, and we are in for a good day. So let's open the event by opening these doors. Good morning. How are you guys today? Sure. So we have team SYK ready over here. Guys, are you nervous?
A little bit, yeah.
You need to be louder.
A little bit, yes.
Yeah?
Yes.
All right. So I'm going to leave the project to you. He's going to handle the camera. So you look in there to the judges and explain your projects. All right? Good luck. I'll be holding the mic.
Okay.
Go for it.
Okay, so good morning to one and all. My name is Ruben De Costa, and I'm here with my colleague Peter George. And we're from Mechanical Engineering third year, and we'll be explaining over two of our projects that we constructed. One is called the counterflow humidifier, and the second one is the centrifugal humidifier. Now, I'll first explain over the counterflow, and then Peter will handle the centrifugal. So our setup is pretty simple. It consists of a duct. The duct has an inlet where the blower will be placed. Now, the air from the blower will pass from the inlet to the outlet, and it passes through this packing material which we have placed in the center. Now, it consists of two reservoirs. One is at the top and one reservoir is at the bottom. The top reservoir will be supplying the water to our packing material in the center. The water will flow in downwards direction. It will be collected in the bottom reservoir and be recirculated to the top with the help of a pump. Now, as air flows in the direction of the packing material and the water flows vertically downwards, the flows of air and water have an intersection. So that is why we call this setup a counterflow humidifier. We achieved a humidification level of about 75 to 85% in this setup. Now, Peter will explain the centrifugal humidifier.
So, good morning to one more present here. I'm Peter, and I'll be explaining the centrifugal humidifier. So, I'll first explain the components. So, over here is the inlet, and this is the duct where the packing material is placed, and this is going to be our outlet. So, if you look at the bottom part of our project, you can see there's a reservoir which is filled with water, And there's a pump here which will be supplying the water into the duct. And over here is the motor which is connected to a shaft by a pulley system. Now I'll be showing you guys the working. Sound right? Okay, so over the inlet there will be a blower present and the air is pumped into the duct. Now as you can see, the water inside the reservoir is pumped into the duct with the help of a pump. And if you can see here, there's a motor which is connected to the shaft by the help of a pulley. Now this causes a rotation inside the duct which causes the centrifugal action, and hence the air entering will be humidified and will exit outside as humidified air. Now, the result of this experience, we achieved about 65 to 75% humidity. Thank you.
All right. So do we have any questions from the judges? Ruben, you also can come. So we'll take the questions.
Yes, hello. Can you hear me?
Okay. Yes.
Are you able to hear me? This is Muhammad Ibrahim. I have one question. Do you done any calculation for the water flow and the airflow in the system? Can you show us a sample of that?
We have varied our velocity of the air at the inlet, and we achieved different set of humidification for each reading. The water flow, we have just kept the flow constant.
The second question, do you have any measurement for the air temperature outside or the water temperature in it? Did you try to do any measurement?
Of around 17 to 18 degrees Celsius, and we achieved humidification of about 70 to 80%. Yeah, that's about it.
Okay, thank you.
Thank you. Thank you.
Thank you, sir. Any more questions from the judges? All right. That's it from here. Thank you, Ruben. Thank you, Peter. So let's move on to the next team, which is going to be online. Over to you, Nafisa.
Between doing
Welcome back. Since we have a small delay online, so we're going to continue with one more offline team. Before that, we have Ruben for a few minutes. Ruben, could you come back in? Well, before the other team sets up their project, I want to know more about your project. Okay. Nothing technical, don't worry. Okay. Don't get scared. Yeah. It's going to be normal. Okay. So you had 5 people in your group, correct?
Yes.
So who's the most hardworking one?
I mean, we have 5 people, and all 5 have contributed equally, which is why we were able to create our projects in time. So yeah, everyone was hardworking. Yeah.
So what was your motivation to build this project? Like, what was the one idea which triggered you to build this one?
So a lot of buildings in Dubai, thermal comfort is an important factor which has to be maintained, and which means the humidification level should also be maintained in those buildings. Ashrae Standard 55 suggests that we have a thermal humidification range of about 60% for thermal comfort. So to achieve that, we have these two setups, and we analyzed which setup gives the most thermal comfort range.
So, Peter, what about you? What was your experience working on this project? What was the new thing which you learned by building this project?
Well, I learned a lot about humidification and stuff because I didn't know anything about it. And yeah, it was like a new learning experience. Finally, able to build something with a team. Like in first year, we just built like very simple stuff, nothing very. So this is like a really good learning experience for all of us. So yeah, we were able to put our hard work in, and yeah, we achieved it.
So you guys were the first group for the whole event today. There are around 23 participants, and you guys are the first ones.
Yeah.
Generally, the first team has a responsibility on them. If you do well, other people get that motivation to do better. If you made some mistakes, other people will be like, okay, let's
Hi,
not make
Mevin.
this mistake. So how did you handle that pressure while doing your presentation? You did a pretty good presentation. I loved your presentation.
Honestly,
You look kind of nervous.
You were kind of
definitely nervous.
We
but,
did
all we had to do is just explain our point of our projects, and to the rest of the team, I can just wish them all the best. For it.
Thank you for joining us.
Thank you.
I really wish good luck for your project.
Thank you.
Okay, thank you. That's
Hi,
it
Mevin.
from Team SYK. We
Mevin.
have the next group ready. So let's move on there. Come with me.
Mevin, can you hear me?
How are you? My God, I can see. Hello, sir.
Yes. What is the name of the first team, please?
So Team SYK.
SYK. And the next and the current team.
What's your team's name? Tech Phantoms, sir.
Again, please.
Tech Phantoms.
X Phantoms. Thank you a lot.
Thank you, sir. Okay, so I can see a lot of energy coming out from you. Yes. So who's going to speak first?
Yeah, so yeah.
Okay, first introduce your team, introduce your team members, and then let's get started, all right? So come closer. Start.
So hi, we are Tech Phantoms. So I myself, I'm Samina. This is Srijesh, that is Siana, Jessica, and Aisha. So we all together, we have put in all our efforts, and we have constructed a vertical axis wind turbine. Usually you might be seeing the wind turbines or everything in horizontal axis. But this is something different from that, which is having the vertical axis. Here all the blades are placed vertically, and their axis is parallel to the y-axis. That is why we call vertical axis. And they rotate this way, as the windmill that you have seen outside, right? That rotates this way because the blades are placed in such a way that they are in horizontal axis, whereas this is vertical axis. So here I move on to Srijesh to tell about the mechanism of this project.
Thank you, Samina. So here the blades of the turbine have been made with the help of metal sheets. So the length of the metal sheet is approximately 18 centimeter, and since these blades have been riveted across the shaft, and the shaft has been connected with the alternator over here, and the alternator has been then connected to the bulb which glows with the help of rotating the blades. And the problems that have been faced will be explained by Siana.
Yeah, we have faced problems attaching the metal sheets to the shaft, as they wouldn't solder themselves, as the metal is too thick. So we have riveted it, and yes, at the beginning we faced problem with the wind velocity. We had less power in our, we used hair dryers to blow it, but it wasn't possible. So we took another motor with 60 watts. It was not possible. Then we took a motor with 500 watts, and that's when it starts moving.
Yeah, so now we'll show you the working of the model. So here we've connected the blower. So this gives the air force. So the air velocity, the minimum air velocity that we required in our project to rotate these blades is, as we measured in the anemometer, we recorded the value of 33.9 meters per second. That was the velocity. So here we blow the wind and show you how the electricity is generated. Here we use sustainable energy of conversion of wind energy to electrical energy. So here we go. our project, Vertical Axis Wind Turbine, and thank you so much.
Thank you.
So judges, do we have any questions?
Hi. Can you hear me?
I have a video to show.
Take the judges' questions first.
Hello?
Yeah.
Yes, ma'am.
So my question is, thank you, first of all. You spoke about the mechanism, but I want to know more about how the applications of this in the real world differs from what typically already exists, like the horizontal axis wind.
Yeah, like now whatever is placed outside in the countries, like in the world wide, we have the horizontal axis. Yes, it does have some advantages over the horizontal axis wind turbine. Yes, this is cost effective. This is eco-friendly. Yeah, so the installment rate is also way better than the horizontal axis wind turbine. So this is economical. Yeah, so in all perspectives, yeah, it plays a good role. The vertical axis wind turbine.
Can you elaborate a bit about how it's more like cost effective?
Could you just repeat, please?
Can you elaborate a bit more about how it's more cost effective? Like in what sense?
In what sense means here we use the metal blades and the rotational, and it requires even minimal space than the horizontal axis wind turbine, because the horizontal axis wind turbine, they rotate in this way, whereas this rotates itself. So the space space required is way minimum than the horizontal axis wind turbine. See the way it rotates within the axis. The diameter of the circle, it's fixed within a diameter of 17 centimeters. So as it rotates, it requires the minimum space. Whereas the horizontal axis, it rotates that way. So it requires more space than the fitting body of the turbine.
Okay, great. Thank you so much.
Welcome, welcome. Thank you, everyone.
Do we have any other questions from the judges?
Thank you a lot. It is really amazing application and good utilizing for the energy. My question here, or it is just a suggestion to make it more practical. How about if you didn't think about to make a shade in half of it? Because in real application, the wind will come, will push it in the both direction. So that did you try to make the wind to push it in one direction? And because if you make simple a shade or half circle shade around it, the wind will push it in one direction and you start to rotate. It is. Do you think about that or?
Yeah, we did think about that aspect as well. So when we place in place where, like in a country like India, where we have frequent monsoon winds, so yeah, it does not like only a matter about the direction which the force of wind comes in. So we tried in that way also. It moves and it rotates in that way as well. Yes, we did consider about that aspect as well.
Excellent, excellent. Thank you a lot. Appreciate it.
Thank you. And just a minute, we have a video to present to you. Yeah, here we have the video.
Okay, judges, I guess we have a video to support their project. So thank you so much.
Thank you so much.
So since you guys are first years, I see the project is amazing.
Thank you so much.
Good luck
Thank you
for the event. This is your first event, no?
Yes, it's our first event.
You had good experience. Project is really good.
Thank
Good luck
you.
for the result.
Thank you.
Thank
Alright?
you. Thank you very
Thanks.
much. Thank you, guys.
All right, guys. Next we have online. So Nafisa, please take over.
Thank you, Sairohit. Now we will start out with our first online group project presentation, which is team concreters from Islamic University of Technology. The participants are Humaira Tasneem Oishi, Saif Nawaz Chowdhury, Mohammed Zidan Shahriar, and Abed Hassan Shaumi.
Assalamu alaikum everyone. This is Tim Concretus from Islamic University of Technology. HVAC. HVAC stands for heating, ventilating and air conditioning. HVAC systems are effectively everything from our air conditioner at home to the large systems used in industrial complexes and apartment blocks. A good HVAC system aims to provide thermal control and indoor comfort. One that is designed using the principles of thermodynamics, fluid mechanics, and heat transfer. It is important to choose a HVAC system that will meet our comfort needs without drawing on excess power and escalating our cost of living. For the advancement of indoor environment control technology in the HVAC industry, Ashrae, American Society of Heating, Refrigerating and Air Conditioning Engineers is an organization devoted to in 2018, the organization has more than 56,000 members from over 132 nations. In this competition, organized by the Ashrae team of Manipal University, Dubai, we tried to blend air cooling and heating in one device to increase people's comfort. We can call it dual conditioner. Materials required for the model are especially the Peltier module, which uses thermoelectric effect to turn the electricity into heat and cold. When voltage is applied in the module, one side of it gets hot and the other side of it gets cold. We used a 12-volt power supply that promises to deliver 10 amperes of current, that is more than the power required for the Peltier module. For multiple cooling units, power supply with more amperage can be used. A 12-volt cooling fan with heatsink was used to radiate the heat from the hot side of the Peltier module. Also, a mini fan for the air intake was used. To control the temperature, we used the module WS1-1209. It can sense the temperature and turn on or off the relay according to the settings. We also used nichrome wires for making the heater. Thermal paste, switch and wires. To make the body, we used 3 mm UPVC sheets. We cut sizes and joined them with glue. These materials provide strength to the body and also provide insulation. Aluminium foil was used to prevent the melting of high temperature areas. Then we mounted the heating side of the Peltier to the big radiator heatsink with some thermal paste. Then we poured some super glue to attach the cooling unit to the body. We also mounted a small heatsink on the cooling side the same way. This part will get colder during operation. To make the heater, we used a small PCB board to make the connection layout. We applied masking tape to the areas that need to remain in the board after etching with ferric chloride. Then we submerged the board into the ferric chloride solution. We shake the container for 10 minutes and then rinsed the board with water. After removing the tapes, we see the connection layout being made. After that, we put connecting rods for the heating coil and tested the heater with 12 volt. Then we placed the heater and glued it in place. We added the intake fan to the body and glued it together. Then we covered the airflow path and sealed it with hot glue. We connected and soldered everything according to the diagram shown. Later, we placed the switch on the front side and soldered the wires.
After that, we set the controller in the position with the help of glue. And feed the thermostat inside, which will directly go in front of the air vent of our device. And lastly, we glued everything together with the help of superglue. Then we wired up the power connection to the power supply. Now we have to set the mode of the operation. For doing this, we need to switch to cool or heat mode. We need to set up the controller to the C mode and set the lowest temperature for cooling. On the other hand, for heating mode, we need to switch the position to H and set the highest temperature for heating operation.
Now, to test the model, we set the mode to cooling and also set the temperature to 24 degrees. We see the temperature dropped gradually from 30 degrees and eventually after 4 minutes it reached 24 degrees and the temperature remained 24 degrees. Then, to test the heater, we set the mode to heating and also set the temperature to 40 degrees. We see the temperature increased rapidly, and when the temperature is 40 degrees, the controller adjusts the heating to stay around 40 degrees. After testing cooling, we took the measures of current consumption for various temperatures. As time passes by, the power consumption decreases to a certain point, then slowly increases to a point.
If we have all necessary tools available, then the cost of the whole project is around 15 US dollar. And if we use multiple Petlier module, then the cost will be increased about 5 US dollar for each extra module with radiator. Then we also need a power supply with more amperage. Now I will discuss the problems we have faced during the project. Transfer of heat and cold is not 100% as because we cannot assure the highest thermal conductivity between Petlier and heat sink. Due to the radiator cannot dissipate 100% heat produced, the cooling does not go under 15 degree. However, adding more of the Petlier module can reach even lower temperatures. Another problem is when the heating coil gets hotter, its resistance increases, resulting in lower power and lower heat production. As we cannot separate the heated air from the radiator, some of the hot air enters the inlet fan, causing less performance. This can be solved by isolating the radiated heat from entering the inlet.
Now, judges, would you please like to ask some questions to the teammates?
What is the name of the team again? Sorry, always I miss it.
So the name is Team Concretos.
Team Computers. Okay, team. What is the number of the team, please, if you have it?
It's 5. Concrete.
It's 5. Ah, okay, thank you. Okay. First, thank you a lot. It is quite good experiment, and I think it took a lot of work with you, getting all these modules and these items. What is the extent of the temperature you tried in it? Did you try to make it lower than 24 degree or higher than 40? Or this is the range which is it should work in it only?
No, it can reach more than 40 degree, of course, if we set it. And the cooling temperature can also reach less than 15, but as we have used one single Peltier module, the cooling is here limited. So if we use more of them, then it can reach lower than 50.
Excellent. Thank you a lot. Great experiment. Thank you a lot.
Judges, would you please like to ask any more questions?
My name is Athar Siddiqui, and from the Northern Pakistan chapter. It is a very good presentation and nicely done. The 3D system very nicely. I appreciate. But you have to keep in your mind the safety also, because you are using the element heater inside the duct. So there should be fire safety is also there. So you must be take care about it.
Thank you, Team Concretos. Now, back to Cyro.
Ready. Welcome back, everyone. Up next, we have the next team over here. Team Nature Cool. Nature Cool. So let's begin with their project first, and then we'll talk.
All right. Actually, we are a team of 5, but few of my friends are busy hosting the event itself. So just 2 of us are representing the project right now. Ours is a rotary humidification system, and we actually applied for Ashrae grant for this project, and we got a grant of $3,650 for the same project. And I shall just open the doors and show you what's inside. So as you can see here, it's a packing which is rotating in water. This packing is being rotated by a motor, and the motor speed can be regulated here. I can make it as slow as possible, and this is the maximum speed. And the reason why I kept this speed is because obviously I don't want water to splash out. Now, this tank which you see here is a supply tank. This tank makes sure there is a maintained level of water in this particular tank. There is actually float valve connected inside, so that when the float valve level is down, it will automatically take in water from the supply tank. Now we have this tank which is being connected by a cooling tank, which is all the way at the bottom. Cameraman, here. All right. So this is the cooling tank. There is an evaporator coil kept inside, and the water is being made cold inside this particular tank. And using a pump, it is being circulated to the main tank so that the temperature in this particular tank is maintained. Now this is the blower, which is aiding the evaporative process. So the blower is connected here, and the blower will pass air through this packing, so that the air at the outlet is actually lower temperature humid air. So that is basic working principle of our project. Now Parvati will speak about the packing which we are using.
Okay, for our project, we are using natural packing material. Right now, we use coconut fiber. We can use other alternative packing materials such as cuss fiber, flash fiber, bamboo fiber. And as you all know, packing material, we are getting it from the nature, so it's more sustainable, more eco-friendly, and it's cheap. There are different processes done for getting the packing material. Right now, we are just using the coconut fiber. After trying the coconut cuss fiber, we just directly use just packing material, which is meshed with the case, and we are using it. And it's more eco-friendly, and we get good air quality.
So I guess she mentioned the packing which we are currently using is actually coconut fiber. You can see it rotating. We made a pattern out of this, and we stuck it to a cage, and that is being dipped inside the tank here, and it is rotating. So that is the basic working principle of our project. Now, I will tell you where exactly we are planning to use this system. This system will be used in mainly added and hot regions, where evaporative cooling is very effective. So, Ashrae standards suggest that relative humidity of 45% to 65% is the thermal comfort range. So, what my plan is, this humid air will be recirculating with the air which is being sucked in from the normal air conditioning system, and when it mixes, it is going to be within that Ashrae thermal comfort range. So, yeah, that's pretty much all about our project.
All right. Thank you so much. Judges, do we have any questions? Please come in. Postmaster.
Yeah. Thank you a lot. Appreciate your work. Really, it looked like amazing, and you should have submitted a lot of document to grant the Ashrae support in this project. Did you put any testing point in the to test the humidity before and after in this module or not?
Yes, yes. Actually, I will tell you about that. The relative humidity, when we tested it, it was 25% relative humidity, and out of the packing, we are getting 92% relative humidity. So that much humidification we are getting.
Excellent, excellent. Thank you a lot. That's all from my end.
Any more questions from judges?
No, thank you. But Mevin, I want to tell you something. Sometimes while they're speaking, we can't hear them so well. So for the next group, would you mind just making sure the microphone's very close to them?
Sure, ma'am. Yes, ma'am. We'll do that. Yeah.
Thank you, ma'am.
Thank you, ma'am. So, Team Natural Cool, it was fantastic. Your project is very impressive. Good luck for the results. Thank you. Thank you. Thank you. Over to Nafisa next.
Thank you, Sai Rohit. Now we have our second online team, which is Team Radiant Cool from Sharad Institution of Technology College of Engineering, Yatra. The team members are Subham Kulkarni, Suraj Haswal, Bharashta Ambade, Sudhanshu Rankambe, Avinashpe Husni. Please take over the stage. Thank you. Judges, do you have any questions for the teammates?
Yeah, actually, so many questions. If they're here, it was so fast. I couldn't catch anything from the information they provided. So if they can give us a brief, then that would be great.
Hello.
And also the group name, please. Yeah. Hi.
Yes. Hi. Hello, ma'am. My name is Shubham Kulkarni. Hello.
Hi, Shubham. Yes.
Am I audible, madam?
Yes, I can hear you.
Actually, madam, due to the lockdown in our area, we can't make the video of our model.
It's okay.
So this is a short notice video.
Hmm.
We did a radiant cooling technology for a small room, which
What's
is
your sorry?
Hello.
What's your group name?
Team Radiant Cooling.
Radiant Cooling. Okay. Yeah, you can carry on.
Yes. Actually, madam, we did a project radiant cooling technology for a classroom cooling. For that, we took 4 feet by 4 feet UPVC material room, and height of the room is 7 feet. And for water chiller, for chilled water supply, we made a water chiller by taking a 80-liter water cooler, and the capacity of the compressor is 1.2 tons of the compressor we used for the chiller. And also our project is funded from Ashrae, Indian Society of Heating, Refrigeration, Air Conditioning Engineers, under SRPG proposal, student research grant, with 50,000 rupees. And our research paper, our review paper is also published in ADR journal.
Thank you, judges. Now back to Sai Rohit for another team.
Welcome back, everyone. Moving on to the next project. Here we have a team from first years. Hello, what's your name?
Oh, hello. My name is Furqan, and this is my group. This is Wendell, and this is Vishnu, and we are the crew.
Nice to meet you. Good luck with your project.
Oh, thank you.
Take the mic. Go ahead.
All right. So in our household, we have many hot objects. So we made a solution to make the household a little safer.
So first I'm going to talk, hi, my name is Vishnu. So let me just explain what it is exactly. First of all, we thought of making a cooling pad for iron boxes, not only iron boxes, it's a universal purpose for now. And so right now we just took an example. We took iron box. As it heats up and it takes a lot of time to cool down naturally. So what we have done is we have created a cooling pad over here where we keep the iron box after use, and this cooling pad cools it much faster than naturally. So my friend here is going to explain what it is.
Okay. Hey guys, I'm Wendell, and yeah, I'll just take you through the project. So basically, we have like a reservoir over here. It keeps it has a pump inside, and the pump is connected to 2 pipes. As you can see, if the camera will go down, you can see 2 fans over here. You'll see a cooling pipe. These 2 pipes are connected to the cooling pipe, has an inlet and an outlet. And the cooling pipes are connected to this top sheet over here. And the cooling pipes, the copper tubes are connected to the sheet, and the sheets have a bunch of holes. So the fans inside will help with the ventilation. So as the coolant passes through, it's just supposed to reduce the temperature much more faster of the heater device over here. Yeah, that's basically it.
Coming to why we did this is because the reason why we had done this, because this is going to be a hazard, keeping it that way, as it takes much longer time to cool down. So this device cools it faster. The cost involved in this is 100 dirhams in total. So that's pretty much. And we also calculated the timings. We recorded timings, how long it takes. Naturally, for cooling, it takes around 35 minutes. With the cooling pad, it takes around 26.5 minutes. So,
I would like to even point out that we were actually able to make this 25% more efficient at losing heat. So like, yes, from 35 minutes, we got it back till 25, 26 minutes. And I think that's a really good time for what we have done. Yes.
And if you calculate the total time saved, it would be around 9 minutes. That would mean it's 25% less time taken. And the pump that we use is only 25 watts, so we are in fact using less power than you would normally use to cool something like this down. So yeah. Thank you. Yeah. Thank you. Any questions?
Yes, judges, if you have any questions, please put it forward to the team.
For cooling, they use ice or what exactly?
We used a mixture of water and coolant.
Water and cooling. Okay. And for heating, you use iron in the other side.
Yeah, this could be used for any other device as well. Like you could use this like because the surface is pretty big, you could use it for any device within the given temperature range. As long as it's like less than 200 degrees Celsius.
Great. Thank you a lot. Great work. Thank you a lot. Appreciate it.
Thank you.
All right, what's your team name again?
Any more questions, judges?
Yes, I'm asking about the team name.
Team name.
Yeah, the team name is the crew. The crew.
I think number 10.
Yeah, I got it. Thank you.
Thank you. Thank you so much. Well, that was a good project, the crew. So good luck for your results. All right. Thank you. See you. Okay. All right. Next, we have one submission from online. Nafisa, over to you.
Now we have team GCC Barton Hills from Government Engineering College, Barton Hills, Trivandrum. The team members are Abhinav, Jobin Tommy, Josin Aju Jos.
You understand the song, right? You understand the song, right?
Refrigeration system using Peltier module. For the Peltier module refrigeration system, the brain of the system is thermal relay. Now we'll be discussing how the temperature of the thermal relay is set and is working. To supply power to the thermal relay and to take power from the thermal relay, there are 4 ports. Ground, 12 volt, K1, K0 are the 4 parts. For setting the temperature, there are 3 switches, set, plus, minus switches. Using the 3 switches, we are setting the lower and upper limit of the temperature. Now we are going to look into the thermal relay connection. The negative 12 volt supply is connected to the ground of the thermal relay. Load circuit negative is also connected to the ground of the thermal relay. 12 volt supply is connected to the 12 volts load of the thermal relay. The 12 volts load from the thermal relay is connected to the K node of the thermal relay. The K node is then connected to the K1 port, and from K1, the connection continues to the positive side of the load. We are going to show a demo of a refrigeration system using a Peltier module. The temperature which is displayed on the thermal relay is the temperature of the cold side of the Peltier.
ക്രിയേറ്റ് ചെയ്ത സർക്യൂട്ടാണിത്. ഇപ്പോൾ നിങ്ങൾക്ക് തെർമൽ റിലേയിൽ കാണിക്കുന്നത് അത് ടെസ്റ്റ് പ്രോബ് വെച്ചിരിക്കുന്ന പെൽറ്റിയർ മൊഡ്യൂളിൻ്റെ കോൾഡ് സൈഡത്തെ ടെമ്പറേച്ചറാണ് കാണിക്കുന്നത് 28 ഡിഗ്രി സെൽഷ്യസ്. ഇവിടെ ഇപ്പം ടെസ്റ്റ് പ്രോബ് പെൽറ്റിയർ മൊഡ്യൂളിൻ്റെ കോൾഡ് സൈഡും പെൽറ്റിയർ മൊഡ്യൂളിൻ്റെ ഹോട്ട് സൈഡ് അടിയിൽ വാട്ടർ ബ്ലോക്ക് വെച്ചിട്ടുണ്ട്. വാട്ടർ ബ്ലോക്കിലേക്കാണ് ഹോട്ട് സൈഡ് വരുന്നത്. ആ ഹോട്ട് സൈഡത്തെ ചൂട് നമ്മൾ വാട്ടർ കൂളിംഗ് സിസ്റ്റം വെച്ചിട്ട്.
Now the temperature that is shown on the thermal relay is the temperature that is on the hot side of the Peltier is connected to a water block. And we use a 12-volt DC pump to supply the water through the water block. And the Peltier is placed on top of the water block, and the heat from the hot side is dissipated through the water. The system is connected to the thermal relay through the C of the thermal relay.
വോൾട്ടേജ് അക്രോസ് ആയിട്ട് നമ്മൾ ഇപ്പം കണക്ഷൻസൊക്കെ കൃത്യമായിട്ട് കൊടുത്തിട്ടുണ്ട്. ഇനി നമുക്ക് ടെമ്പറേച്ചർ എങ്ങനെ സെറ്റ് ചെയ്യാന്നുള്ളതിലേക്ക് നോക്കാം. ഇവിടെ നിങ്ങൾക്ക് തെർമൽ റിലേയിൽ 3 ബട്ടൺസ് കാണാം. അതിൽ നമ്മൾ ഇപ്പം റെഫ്രിജറേറ്ററിന് വേണ്ടിയിട്ടാണ് യൂസ് ചെയ്യുന്നത്. അപ്പം അതിന് വേണ്ടിയുള്ള സെറ്റിങ്സ് നോക്കാം. ഈ സെറ്റ് എന്ന് പറഞ്ഞിട്ടുള്ള ബട്ടൺ അമർത്തി പിടിക്കുക. അമർത്തി പിടിക്കുമ്പം P0 എന്ന് പറഞ്ഞിട്ടുള്ള ഓപ്ഷൻ കാണും. അപ്പം അതിൽ നമ്മൾ ചെയ്യാൻ പോണത് അത് P0 എന്ന് പറഞ്ഞ ഓപ്ഷൻ ഒന്ന് ജസ്റ്റ് പ്രസ് ചെയ്ത് കൊടുക്കുക. അപ്പം H എന്ന് കാണും. ഇത് 2 രീതിക്ക് നമ്മൾ ഈ തെർമൽ റിലേ വർക്ക് ചെയ്യിക്കാം. ഒന്ന് ഹീറ്റിംഗ് സർക്യൂട്ടിന് വേണ്ടിയും ചെയ്യാം, അല്ലെങ്കിൽ റെഫ്രിജറേറ്ററിന് വേണ്ടിയും ചെയ്യാം. H നമ്മൾ ഹീറ്റിംഗ് സർക്യൂട്ട്, അതായത് ഇൻക്യുബേറ്ററിനൊക്കെ ചെയ്യുമ്പം H വിറ്റ് ചെയ്യണം. അല്ല നമ്മൾ ചെയ്യുന്നത് ഫ്രിഡ്ജ് ആണെങ്കിൽ C എന്ന് പറഞ്ഞിട്ടുള്ള ഓപ്ഷൻ വെച്ചിട്ടാണ് ചെയ്യേണ്ടത്. നമ്മളിപ്പം ഫ്രിഡ്ജ് ആയതുകൊണ്ട് C എന്ന് പറഞ്ഞ ഓപ്ഷൻ ചെയ്യുന്നു, C സെറ്റ് ചെയ്യുന്നു. പിന്നെ P1 എന്ന് പറഞ്ഞ ഓപ്ഷൻ വരും. അതെന്ന് വെച്ച് കഴിഞ്ഞാൽ ഇതിൻ്റെ ലീസ്റ്റ് കൗണ്ടാണ്, ഇതിൽ മെഷർ ചെയ്യുന്ന ടെമ്പറേച്ചർ ലീസ്റ്റ് കൗണ്ടാണ്. നമ്മൾ 0.1 ഡിഗ്രി സെൽഷ്യസ് ആയിട്ടാണ് സെറ്റ് ചെയ്തിരിക്കുന്നത്. സെറ്റ് ചെയ്യുക, അപ്പ് കൊടുക്കുക, പ്ലസ് കൊടുക്കുക. പ്ലസ് ചെയ്യുമ്പോൾ P2 എന്ന് പറഞ്ഞ് കാണും. അപ്പോൾ നമ്മളെ സിസ്റ്റത്തിൽ വരുന്ന മാക്സിമം ടെമ്പറേച്ചറാണ് P2. 28 സെറ്റ് ചെയ്യുന്നു. പിന്നെ P3 എന്ന് പറഞ്ഞിട്ടുള്ളത് അത് നമ്മൾ ചെയ്യുന്ന സിസ്റ്റത്തിലെ മിനിമം ടെമ്പറേച്ചറാണ്. അത് 10 ഡിഗ്രി സെൽഷ്യസ് ആയിട്ടാണ് സെറ്റ് ചെയ്യുന്നത്. ഇത്രയേ സെറ്റ് ചെയ്യാനുള്ളൂ. ഓക്കെ, ബാക്കിയൊന്നും നമ്മൾ നോക്കണ്ട. ജസ്റ്റ് ഇത്രയും നേരം വെയിറ്റ് ചെയ്ത് കഴിഞ്ഞാൽ ഈ ഓപ്ഷൻ പോയിക്കോളും. നമ്മൾ ടെസ്റ്റ് പ്രോബിൽ എത്രയാണ് ടെമ്പറേച്ചർ കാണിക്കുന്നതെന്ന് കാണാൻ പറ്റും. ഇപ്പം ഓൺ ആയിട്ടുണ്ട്. LED ലൈറ്റ് കത്തുന്നത് കണ്ടില്ല, അതായത് നമ്മൾ സെറ്റ് ചെയ്ത് 28 ഡിഗ്രി സെൽഷ്യസിനും മേലെയായിട്ടാണ് അത് കാണിക്കുന്നത്. നമ്മൾ 18-28 ഡിഗ്രി സെൽഷ്യസ് വരെയാണ് നമ്മൾ റേഞ്ച് സെറ്റ് ചെയ്തത്. അതിൽ നമുക്ക് എത്ര ഡിഗ്രി സെൽഷ്യസ് ആകുമ്പോഴാണ് നമ്മൾ ഈ റിലേ വർക്ക് ചെയ്യേണ്ടത് എന്നുള്ളത് സെറ്റ് ചെയ്യും. അതിന് ജസ്റ്റ് ഇങ്ങനെ വന്നു കഴിഞ്ഞാൽ ജസ്റ്റ് സെറ്റ് ബട്ടൺ ഞെക്കുക. അപ്പോൾ ഇങ്ങനെ ബ്ലിങ്ക് ചെയ്യണ കാണാൻ പറ്റും. അപ്പം ഇപ്പോൾ ഇവിടെ 26 ആണ് കാണുന്നത്. നമ്മളത് റെഡ്യൂസ് ചെയ്തിട്ട് 25 ഡിഗ്രി സെൽഷ്യസ് ആക്കാം. 25 ആക്കിയിട്ടുണ്ട്. ഇപ്പം നമ്മളെ ടെസ്റ്റ് പ്രോബത്തെ ടെമ്പറേച്ചർ 25-ൽ കൂടുതലായി കഴിഞ്ഞാൽ നമ്മളെ സർക്യൂട്ടിലൂടെ കറണ്ട് ഫ്ലോ ചെയ്യും. നമ്മളെ പെൽറ്റിയറും പിന്നെ വാട്ടർ പമ്പും വർക്ക് ചെയ്യും. വാട്ടർ പമ്പ് വർക്ക് ചെയ്ത് കഴിഞ്ഞാൽ പെൽറ്റിയറും വാട്ടർ പമ്പും വർക്ക് ചെയ്ത് കഴിഞ്ഞാൽ നമ്മൾ പെൽറ്റിയർ വർക്ക് ചെയ്യാൻ തുടങ്ങും. അപ്പം കോൾഡ് സൈഡ് നമ്മളെ പ്രോബ് വെച്ച് കൊടുത്തുള്ള ടെമ്പറേച്ചർ കുറയാൻ തുടങ്ങും. അത് കുറഞ്ഞ് 25 ഡിഗ്രി സെൽഷ്യസിൽ കുറയാണെങ്കിലാണ് നമ്മൾ ഇത് വർക്ക് ചെയ്യാം. ഞാനിപ്പം ഈ വയർ കണക്ട് ചെയ്തിട്ടില്ല, വയർ കണക്ട് ചെയ്ത് കാണിക്കാം. ഇപ്പം വയറൊക്കെ പ്രോപ്പറായിട്ട് കണക്ട് ചെയ്തിട്ടുണ്ട്. ഇപ്പം നമുക്ക് ഇത്തിരി നേരം വെയിറ്റ് ചെയ്ത് നിൽക്കാം. ഇപ്പം 22 ഡിഗ്രി സെൽഷ്യസ് 22.8 ആണ് കാണിച്ചുകൊണ്ടിരിക്കുന്നത്. ഇപ്പം 23 ആയിട്ടുണ്ട്. കൃത്യം നമ്മളെ ടെമ്പറേച്ചർ പ്രോബ് ടെമ്പറേച്ചർ 25 ഡിഗ്രി സെൽഷ്യസിൽ മുകളിലായി കഴിഞ്ഞാൽ നമ്മൾ ഈ പമ്പും പെൽറ്റിയറൊക്കെ വർക്ക് ചെയ്യാൻ തുടങ്ങും. തെർമൽ റിലേ ഓണായിട്ട് നമുക്ക് വെയിറ്റ് ചെയ്യാം. ഇപ്പോൾ 24, 24.5, 24.6, 25 ഡിഗ്രി സെൽഷ്യസ് കഴിഞ്ഞിട്ടുണ്ട്. അപ്പം നമ്മളെ സിസ്റ്റം തെർമൽ റിലേ വർക്ക് ചെയ്തു. അപ്പം വർക്ക് ചെയ്ത സമയത്ത് പെൽറ്റിയർ മൊഡ്യൂള് വർക്ക് ചെയ്തിട്ട് ടെമ്പറേച്ചർ വീണ്ടും കുറഞ്ഞു, 24-ലും താഴെയായി. അപ്പം നമ്മളെ 25-ൽ കുറഞ്ഞുകൊണ്ട് ഓഫായി. ഇങ്ങനെയാണ് നമ്മളെ സിസ്റ്റം വർക്ക് ചെയ്യുന്നത്. ഇത് യൂസറിന് വേണമെങ്കിൽ വളരെ കംഫർട്ടബിളായിട്ട് എത്ര ഡിഗ്രി സെൽഷ്യസ് വേണമെങ്കിലും സെറ്റ് ചെയ്യാം. ഇപ്പം 25-ൽ കൂടുകയാണെങ്കിൽ ഇപ്പം ഓണാവും, നിങ്ങൾക്ക് കാണാൻ പറ്റും. ഓക്കെ, എങ്ങനെയാണ് നമ്മൾ സിസ്റ്റം വർക്ക് ചെയ്യുന്നത് എല്ലാവർക്കും മനസ്സിലായി എന്ന് വിചാരിക്കുന്നു.
12-volt 6 ampere adapter connects to the supply, which is connected to the switch, and then it's connected to the relay, which has been discussed before. The relay is connected to 12-volt DC pump, Peltier module, and a CPU fan. We are using a parallel connection to maintain 12 volt through the circuit.
പമ്പ്, പെൽറ്റർ മൊഡ്യൂള്, പിന്നെ CPU ഫാനിലേക്കും നമ്മൾ കണക്ഷൻ കൊടുത്തിരിക്കുന്നത് പാരലായിട്ടാണ്. ഈ 3 ഡിവൈസസും 12 വോൾട്ടിൻ്റെയാണ്. അതുകൊണ്ട് വോൾട്ടേജ് 12 വോൾട്ട് കിട്ടാൻ വേണ്ടി നമ്മൾ പാരലൽ കണക്ഷനാണ് യൂസ് ചെയ്യുന്നത്. പെൽറ്റർ മൊഡ്യൂളത്തെ ഹോട്ട് സൈഡത്തെ എക്സസ് വരുന്ന ഹീറ്റ് നമ്മൾ റിമൂവ് ചെയ്യാൻ വേണ്ടിയിട്ട് ആണ് 12 വോൾട്ട് പമ്പ് യൂസ് ചെയ്യുന്നത്. ഹീറ്റ് വാട്ടർ ബ്ലോക്കിലേക്ക് എക്സ്ചേഞ്ച് ചെയ്യും. വാട്ടർ ബ്ലോക്കിൽ വാട്ടർ പ്രോപ്പറായിട്ട് സർക്കുലേറ്റ് ചെയ്യണതാണ് പമ്പിൻ്റെ യൂസ്.
Now we are showing the refrigeration system. We are using a foam board to build the refrigerator and use it to thick thermocol as insulation. The Peltier module is connected to the top of the refrigerator, and the hot side is connected to the water outside the refrigeration, and the cold side is inside the refrigerator. That completes our system.
ബോക്സാണ് കണ്ടെയ്നറായിട്ട് യൂസ് ചെയ്യുന്നത്. ആ ബോക്സിൻ്റെ ഉള്ളിൽ നമ്മൾ 2 സെൻറ്റിമീറ്റർ തിക്നെസ് ഉള്ള തെർമോക്കോളും വെച്ചിട്ടുണ്ട്. സെയിം 2 സെൻറ്റിമീറ്റർ തിക്നെസ് ഉള്ള തെർമോക്കോൾ നമ്മൾ ആ ഡോറിലും പിടിപ്പിച്ചിട്ടുണ്ട്. നമ്മൾ കമ്പാർട്ട്മെൻറ്റിൻ്റെ മുകളിൽ നമ്മൾ സർക്യൂട്ടും
I would like to mention something. As the video was in Malayalam, there is an audio file translating the same video. We would like to play the video for better understanding for the judges. Thank you.
We will be discussing about the working of refrigeration system using Peltier module. For the Peltier module refrigeration system, the brain of the system is thermal relay. Now we'll be discussing how the temperature of the thermal relay is set and is working. To supply power to the thermal relay and to take power from the thermal relay, there are 4 ports. Ground, 12 volt, K1, K0 are the 4 parts. For setting the temperature, there are 3 switches, set, plus, minus switches. Using the 3 switches, we are setting the lower and upper limit of the temperature. Now we are going to look into the thermal relay connection. The negative 12 volt supply is connected to the ground of the thermal relay. Load circuit negative is also connected to the ground of the thermal relay. 12 volt supply is connected to the 12 volts load of the thermal relay. The 12 volts load from the thermal relay is connected to the K0 of the thermal relay. The K0 is then connected to the K1 port, and from K1, the connection continues to the positive side of the load. We are going to show a demo of a refrigeration system using a Peltier module. The temperature which is displayed on the thermal relay is the temperature of the cold side of the Peltier. Now the temperature that is shown on the thermal relay is the temperature that is on the hot side of the Peltier is connected to a water block. And we use a 12 volt DC pump to supply the water through the water block, and the Peltier is placed on top of the water block, and the heat from the hot side is dissipated through the water. The system is connected to the thermal relay through the C of the thermal relay. 12 volt 6 ampere adapter connects to the supply, which is connected to the switch, and then it's connected to the relay, which has been discussed before. The relay is connected to 12 volt DC pump, Peltier module, and a CPU fan. We are using a parallel connection to maintain 12 volt through the circuit. Now we are showing the refrigeration system. We are using a foam board to build the refrigerator and use it to thick thermocol as insulation. The Peltier module is connected to the top of the refrigerator, and the hot side is connected to the water outside the refrigeration, and the cold side is inside the refrigerator. That completes our system.
Now, judges, do you have any questions for the teammates?
No, nothing from my side. Thank you.
Great project, nice one. Even it is a little bit confusing, the audio, and we couldn't catch a lot in the things. Hopefully next time they can even put it above the translation to be easier. Nothing really. It is a GAC team, yeah. The team name.
Yes, it's GC.
Okay, excellent. Thank you.
Thank you. Now we'll go back to Rohit to showcase all the in-campus projects now.
All right, welcome back, everyone. Now we have Team Revival with us with an exciting project. It looks good, so let's begin with them.
Good morning to one and all present over here. My name is Raj from Team Revival, and this is Ashraf. I will introduce my teammates first. Ashraf, Ibad, Pratyush, and Adnan. So we five have made this three-stage bypass flow-through humidifier. So I will start with what is a humidifier. In simple terms, a humidifier hum- uh, in simple terms, a humidifier is just used to humidify the air in a room or a factory. So there are different types of humidifiers called ultrasonic and bypass flow through. Over here, we have made a bypass flow through humidifier. So we use aluminum duct tapes. Then there is this plywood and the PVC pipes, and inside there is a cardboard pad. So and this is the pump over here and the blower over here. So when hot air from blower passes through the duct, the water from the pump, it will flow through the cardboard pad beside of it, and uh, the water will cool the hot air down, and over here from here we will get humidified cold air. So when we measured it yesterday, the the air had a humidity of 98%, and the temperature dropped by more than 4 degrees Celsius. Yeah, the air quality was excellent, and that's pretty much it. So that's how this thing works, and that's pretty much the construction of it. Any questions?
Thank you a lot, and thank you. First, you put your name of the team over here. It make for us clear which
Team
team you
Revival,
are.
sir.
Yeah, it is very clear. You put it over there. How much? I think it is very good in the budget as well. How much the budget cost you for this around?
Budget?
Yeah.
So the budget was about 50 dirhams per person, so about 250 dirhams, sir.
Excellent, 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 excellent. Great work, great work. Thank you.
Any more questions, judges?
No, that's good. Thank you.
Thank you, ma'am.
Thank you.
So thank you, Team Revival. It was a great project presentation from you. So good luck for your result. Thank you. Okay, Nafisa, over to you.
We do not have any more online teams. So back to Rohit to showcase the in-campus projects now. Thank you.
The video will. Okay, thank you, Nafisa. Before we continue with the next team, I would like to clarify if the audio is clear when the participants are speaking.
Yes, it's clearer now when they hold
All
the
right.
mic themselves.
Thank you so much for the confirmation. So up next we have team cooling tower test rig. So, all right. So I'll hand it over to him. Take the tissue first. Safety precautions. Perfect. Explain, introduce your teammates and then.
So good morning. We are Team Trio and I myself am Edwin George. My name is Nevin. Yeah, Sija. So
Sorry.
our project is basically about
Sorry.
cooling tower, as you can see right here. Now cooling tower is a
Hello.
heat exchanger. When air and water is combined, it drops down the temperature. Now Nevin will give a detailed explanation of how our cooling tower project works. Over to you, Nevin.
Thank you. So how this works is, here we have the hot water which is filled in these reservoirs at the top, and the water from it goes into the cooling tower through these pipes on both the sides. And inside our cooling tower we have evaporative cooling pad and a layer of coconut husk. So as the water passes through these two layers, the temperature drops and we get cooler water in the reservoir that is placed at the bottom. So we have an exhaust on the top, which helps to remove all the hot air from the system, and a blower at the bottom to force cold air into the system. So that's how it basically works. So now over to Sija for the outputs.
Hi, my name is Sija. So we used hot water with a temperature of 55 degrees Celsius, and when it reaches to the basin, water basin, it gives out around 35 degrees Celsius. So it's a drop of around 20 degrees Celsius. And our exhaust, it has a temperature of around 31 degrees Celsius. So that's that. And I'll give now to Edwin.
Thank you, Sija. So, judges, any questions regarding the cooling tower?
Thank you a lot. First, what is the name of your team again? Sorry.
Trio, Team Trio.
Team Trio. Okay. Second, thank you a lot. You done a good measurement. And I see you purchase temperature gauges. This is temperature or humidity in the top. The gauges.
Temperature gauges being used.
Excellent, excellent. Yeah, you took a lot of care of the measurement so that you know exactly temperature in and out. This is excellent, excellent, excellent.
And over here, we have a humidifier, a 3-stage humidifier. This is also one of our projects. That is a 3-stage humidifier, where packing material is used at all these 3 layers, and we have an expected output of 99% humidity, with around 20% inlet air and output.
Yeah, excellent, excellent, excellent.
So, judges, any doubts regarding both the projects?
No, great work, great work. Thank you a lot. Appreciate it.
Thank you.
Thank you. Yeah.
Any more questions from the judges' side? All right. So I have something to ask you people. Nothing technical, don't worry again. Just like what I did with the first group. Okay, so who is the most hardworking person in this group?
We can't say that because we are in charge and we have our equal contribution to both the projects.
Okay. So what was your motivation though to build a project?
Well, actually, it's our faculties for starters. Sampath sir has given us idea on how to create a project, and of course, he's guided us. And then it's all about tinkering with materials as well. So how to find out which is more thermal fitting into it. So basically, yeah.
I want you to answer something. How much are you familiar with all the Ashrae standards and things like that? And how did you try to implement something in this project?
Yes, in our 3-stage humidifier we have it's basically an Ashrae related thing, humidifier.
Yeah.
So there we are getting humidity levels, really nice humidity levels within the Ashrae standards. And regarding the cooling tower, it's related to dropping of temperatures of the hot water. This could be applied in buildings where hot water is being supplied. So it can pass through this and everyone can access cooler water in their tanks.
That's really nice. So,
And it's a very low budget.
low budget.
And we use natural materials
Right.
such as coconut husk.
Hmm.
These are natural materials, sustainable materials.
I'm happy that you mentioned sustainable because that's my next question. You know that Dubai is moving towards sustainable 2040 mission, right? So could you explain more on that part? How is your project will help the sustainability thing? Okay, never mind. Just
So, compared our cooling tower, when it comes to our cooling tower, we have tried to make it as eco-friendly as possible by adding more of natural, sustainable materials rather than artificial materials. So, in our cooling tower itself, see, we have used wood, which is a recyclable product, and of course, compared to the cooling tower that are present, it might not have the correct thermal comfort or the output that is expected from a professional cooling tower. But inside as well, we have used sustainable materials such as coconut husk and of course a few layer of packing material as well.
that's really interesting. Thank you so much for your time. All the best for your results.
Thanks.
All the best. Thank you. So let's move on to the next team.
Sairohit,
Mitra.
Srijit here.
So,
Hello, Sairohit.
Come in.
Hello, Sairohit.
Good morning.
Sairohit, hello.
Yes, hello. Srijit.
Yeah, I want to convey something. Team
Yes.
Cool has requested to present their submission again. So
Okay.
can we go with that, please? Right now.
Yeah, sure, definitely. Please, let's go for the
Okay.
online submission.
All right. The judges, Team Cool wants to present again.
Okay, Team Call.
Thank you. Yeah, Team Cool. Thank you.
Hello.
Yes, we can
Hello?
hear you.
Am I audible?
Yes, you are audible. You can continue.
Sudhanshu, are you here?
Yes. Okay.
Yes.
We can start.
So, yes.
So first of all, a very good morning, a very good afternoon to all. The title of our project is Development of Low-Cost Radiant Cooling Technology for Classroom Cooling. We are representing our project again because we faced some technical issues and the judges couldn't hear our voice. Because we have lockdown in our area and the COVID patients are raising day by day here in Maharashtra, we couldn't be able to make the video of our actual prototype model. So that's why we will just explain it. So actually, before we get into the technical data, I would like to share a great news with you all. This is a fully funded project and has granted an amount of rupees 50,000 by Ashrae Society, that is Indian Society of Heating, Refrigerating and Air Conditioning Engineers, under the SRPG project fund. Out of total 130 projects across India, only 8 were selected for the funding, and this project is one of them. Also, we have published a review paper entitled as A Glance on Radiant Cooling Technology for Heating and Cooling for Residential and Commercial Building Application in the ADR journal, that is Advanced Research Publication. Also, we have applied to the American Society of Heating, Refrigeration and Air Conditioning Engineers, that is Ashrae, to get the funding for our future scope of this project. Next slide, Shubham.
Hello. So, for the project, we took a 4 feet by 4 feet room, cube size room. The height of the room is 7 feet, and the working of the project is the radiant cooling requires a chiller, water chiller, to circulate the water throughout the panels. So in our the water chiller is working on a vapor compression cycle. When we the refrigerant we used for the system is R134A. We require the water temperature between 5 degree to 10 degrees Celsius, and we calculate the heat load also. So and according to the heat load, our compressor is about half tons or more. So for our future scope, we took a compressor system about 1.2 tons and 80 liters of water storage capacity, and our results are results are about 25 degrees Celsius inside the room, and when the outside air temperature is about 31 degrees Celsius, we got the inside temperature, radiant mean temperature about 25 degrees Celsius. And the conclusion is, in many regions, it is sometimes difficult to reach acceptable thermal comfort without continuous energy consumptions for heating and cooling by air conditioning systems. These projects describes the system of radiant cooling for commercial use by replacing the AC systems. The radiant cooling system is very useful in hot or dry climates. We design a radiant cooling system for classroom purpose. As we consider the commercial sector example, so the radiant cooling system can be installed in schools, colleges, industries, offices, and warehouses also. We designed and manufacturing the system at very low cost, and it's very economical for the commercial sectors. The temperature drop we have achieved is about 5 degrees Celsius to 10 degrees Celsius from ambient temperature. Thank you, sir.
Thank you a lot. Really, it is. First of all, can I know your location? Because as you said, exactly the weather condition in your area is a big parameter in using radiant cooling.
Actually, our location is Kolhapur, Maharashtra, India.
Okay, okay. So that it is a little bit dry over there.
Dry over there.
Dry
Yes,
weather.
yes.
Yes. This is why this application will be excellent over there in that area. Of course, I know it is a COVID time and the lockdown create all of these hassles, but hopefully soon, yani, we'll get out of this and this disease will vanish and we'll return to the normal life. Thank you a lot. Really, it is amazing experiment, and the good thing that is you approach all type of certification and association. This is also a very good remark in this project. Thank you a lot. Wish you the best luck.
Thank you, sir. Thank you, sir.
Yes, thank you, sir.
Ms. Manna, do we have any questions?
No, thank you. Thank you for
All
reading.
right.
Thank you.
This is the best. This is the Pacific team, yeah.
Yes.
Thank you.
Yes, sir. Yes,
Thank
sir.
you.
Thank you.
All right. Sarohit, you can take over. Hello, Sarohit, you can please continue. You can showcase all the in-campus projects.
Welcome back. Now we have Team Dimitra with us. So please introduce your team and your teammates.
Good morning to one and all. We are from Team Demetra, and my name is Subiksha.
And my name is Alan Charlie.
So the topic which we are going to be presenting it today is basically spiral tube heat exchanger. So you can zoom in here. So this is the topic. So yes, this is a heat exchanger. The word heat exchanger itself expresses that there is a heat transfer which is taking place. So please come closer, we'll show how exactly it's working. So this is the hot water's inlet and this is the outlet. And here we have the cold water's inlet and outlet. You might wonder what is the basic thing, like why are we having hot and cold? So when there is like industrial use or so they basically in industries like chemical industries and so many other industries where we have this hot fluid, we have to cool it. So to cool that particular fluid is what we're using a heat exchanger for. There are many heat exchangers, like there is shell and tube heat exchanger, double tube heat exchanger, so many types of them. But the tube which we are using is quite different. It's spiral tube heat exchanger. Why is it spiral tube? Again, please come. The coil which we are having, this will be the inner cross section for us. This is the shell, which you're seeing it here. And inside, you can see the coil in this format. It is in a helical shape. So if you see the coil, basically it is in this shape. The reason why we have opted for this particular design is, there is a chance for reducing the mass flow rate. So when the flow rate has been reduced, there's more time for heat exchange. That is heat transfer. Heat transfer is basically a sensible heat. So when the hot water is passing through the coil, there will be a heat transfer taking place. Inside the shell, we'll be completely filling it with cold water, cold as in the normal temperature. So for more understanding, so this is the normal temperature which we are using, the normal pump. So here we are having a pump, and these are the tubes. This is for the inlet, and this is from the outlet. And when we switch it on, the temperature which we are having it here is, sorry, it's inside. It's 40 degrees Celsius. Not 40. You can see it's 30. And the temperature which we're giving in the hot water is here. Excuse me. It's around 60 degrees Celsius, the hot water. So when we transfer the hot water inside, please switch on the pump. So when the hot water transfers, we get the water cooled down here. So this is the basic concept. So when this principle works, definitely we get the heat exchange happening, and it's one of the easiest way to cool the temperature of water. It might take time because, as we told you, it's spiral tube heat exchange. The process takes quite a lot, and heat transfer is much better. We have compared this particular result with our lab. In our Manipal lab, we have this particular. These are the pumps which we have used. This is the pump which we have used in cold water, and this is the pump which we have used in hot water. And this is the one which is used in Manipal lab. And this is basically a shell tube heat exchanger. Inside the shell, we have the tubes which are straight. And here we have the coil type. So here if you see the temperature which is being used, there they give around 60 and the result is around 45. Whereas here we are getting a little more lesser than that. It's much more efficient and it's much more effective compared to the other ones. Sorry, the hot water hasn't come out yet. The pump is switched on. If you don't mind. And the basic applications for this pump. It's being used in many areas, industrial areas, and then condensers, boilers. There's so many places where this pump is being used. I mean, this particular heat exchange is being used. And in mainly this chemical industries, and there are petrochemical industries where, again, these heat exchangers are very useful. And this particular design will be very effective. And again, when we're using this, here we're only using hot water, which is basically the hot fluid. But in the industrial areas, we'll have gases like ammonium, and then some other fluids are also available here. So are we getting the result? It's still taking time. I'm really sorry, the time has been taken a bit more. Slightly lifted. We have kept it in a bit in the slanting format so that the water flow is quite easier. It was working right before this project, yes. Turn it around a bit. Really sorry about the time. Yeah. It's hot water. Yes, it will come. Okay, there's a little bit of water that came out. Really sorry, it's taking time.
This is what's seen in the thing, right?
It's still 60 degrees Celsius. The amount of water which came till now, let me just measure that and let you know. I'm sorry, the water still didn't come out, but this was the amount of water that actually came out in the first. You can see that the amount of temperature which has been decreased is up to 25 degrees Celsius. You can see it, 25 degrees Celsius. I'm sorry. But yeah, it is 25 degrees Celsius. So from 60, we have come up to 25. But in the one which we have used in the lab, that is basically the spiral tube heat exchanger. Spiral tube. The one which we have used it in the lab is basically spiral tube heat exchanger, which was only for 45 degrees Celsius. But when you consider it here, it is up to 25. The temperature drop is amazing here. But just that we couldn't do it here properly, the pump is not effective, but hopefully it works soon. Okay, sir. Thank you so much. Not waste time somewhere. The project works, but then the moment it's not working. Yes, Alan.
Yeah,
Yes, sir.
thank you a lot. Really appreciate it. This is one of the best application normally, the heat exchanger and how you can build it. In your previous testing, did you could get any logging or measure to the reduction in the temperature through the heat
Yes,
exchanger previously? Do you have any result from previous record?
Yes, sir. We have got it around 20 degrees Celsius.
Excellent,
Now
excellent.
it's only 25, but before we got 20 degrees Celsius, the temperature is very low since it is spiral tube. Spiral, as we all know, the temperature, I mean the coil, right? So there's more flow. The flow rate is as low as possible, and also the heat transfer takes more time here. Because in
True.
the other tubes, if you see, it's just straight, direct. So direct heat exchange kind of has less effectiveness. And also we are using only one coil, so more water is being given, and it takes as less as time. So definitely the temperature has been effectively decreased.
No, great work, great work. Thank you a lot. Appreciate it.
Thank you, sir.
Thank you so much. That was very good.
Well, we have any doubts?
No, I'm saying thank you so much. That was a very good explanation and demonstration. And don't worry about the pump not working. It's okay.
Well, that was a good, well thought and applied project. Thank you so much. Good luck for your results. Thank you. Right? Thank you. Okay, up next we have the next team, Scientech, and they're ready for the presentations. So yeah, please introduce yourself first, then introduce your team, then go ahead explaining your project. So good morning everyone, I'm Sanat Joshi, this is Fatima, this is Paul. We are representing Syntech and we have made a desert storm, which is basically a desert cooler. So I would like to start off with why we chose a desert cooler and not a traditional air conditioning system. So that is because air conditioning systems, especially during summers in the Middle East, have to be operated for a very long time, which causes high electricity bills and high maintenance costs. So we thought if we use the evaporative cooling technology, which has been in use for over 1,000 years, we could reduce the costs. So that is the reason, the motivation behind why we went with evaporative cooling technology instead of traditional air conditioning units. So now I would like to speak about its construction. We have used thermocol, which has been reinforced with aluminium on the outside to give it structural strength. The thermocol being very lightweight, it complements well with the aluminium, which makes it sufficiently strong to bear all the loads. Inside it is a fan, a honeycomb cooling pad, some filtering mesh, and a service door on the other side to access the components inside. So that's basically how this thing has been designed. We have tried our best in keeping it a no-frills design, which keeps it very simple to maintain. All the parts are readily available and are very cheap as well. So you can have efficient cooling at a fraction of cost of an AC. So that is why we went with these materials. So at this point, I'd like to specify one thing. This isn't a project just made to compete in a competition. This is an industry-ready product, and it can be put out in the market straight away. So we have kept in mind all the requirements that customers normally have. We have kept the costs down. Let me talk a little more in depth about the construction of this thing. This is a monocoque frame, which means all the loads are taken by the outer shell. Inside it is a central airflow duct where the air comes in from the behind. It goes to the honeycomb cooling pads. It gets cold. The heat exchange takes place. It goes ahead to the fan, and it is circulated outwards through a sufficiently powerful fan ahead. And these thin meshes provide filters, and they don't let any debris or impurities to go through into the airstream. So that's that. I'll like to briefly discuss the problems we faced during building this thing. So being first year students, we don't have a lot of experience building projects. So the biggest problem we faced was fabrication of these outer shells. We couldn't take proper dimensions. We did take proper dimensions, but we couldn't fabricate it to our exact requirements, which did cause a few gaps and a few overlaps at some positions. So what we did was we removed those parts, we modified them and refabricated them, and made sure that it fits to our requirements exactly. And we have ensured that it is a very snug fit, and it is a very compact portable cooler. The second thing was we have a remote water container system in which water is stored and is pumped upwards through tubes. We face a lot of water leakages in early stages, so we use Teflon tape to solve that problem. Now we'll talk a little bit about the economics, the money that was spent in getting all this thing assembled, and Fatima will talk about that.
Yeah, so the total price spent on this product is around 145 dirhams. The honeycomb pads that we use are for like around 25, and this cardboard is for around 45, and the fan is for 35, and the tubes that we use, it's around like 20 dirhams. And the water container that we use inside this is already like reused, like we used it. And we all supported this with the wooden sticks, which is right like around 10 dirhams. And all the miscellaneous support is for like 15. So that's how much we spent on this product. That's it. Yeah. Yeah.
So on this side, we have a remote water container system. My friend Paul will be operating it, and we'll get the honeycomb pads wet through the tubing system. Can you start pumping it? This is a service door through which we'll be accessing the fan. And yeah, as you can see, the water is being pumped. It is being sprinkled onto the honeycomb pads. There is a tin tray underneath which collects all the water, draining it off. It has a locking mechanism. We can unlock it and slide it out. Now that the pads are wet, we will switch on the fan. Air is being sucked in from the rear through the cooling pads, and it's being thrown out from the front end. The fan has two modes. We can go for high cooling as well, depending on your requirement. One big advantage that we have over traditional ACs is if we don't intend to cool the air, and if we just want circulation, we can keep the water system off and just operate the fan, which is something you cannot do with ACs. The compressor is always coupled to it. So this is why we can achieve more cost savings over traditional ACs. So that was the Desert Storm. Thank you.
We'll take this question from the Sure. Hello. So any questions, please?
Thank you a lot. Really great work as well, and it seemed to be really a lot of effort. Even you try to see the maintenance and how you can approach the maintenance, the fan. Yani putting the maintenance hatch over there for the fan is a smart idea. That is, you make it working. The only things what I don't see, did you try to measure the air temperature before and after? Did you take a look before to see how much effective it is?
Yes, sir. So from statistics, we know that desert coolers have an efficiency. They can cool down air up to 20 degrees Celsius. The reason we did not give you actual readings is because all this prototype was made inside a lab. So the air which is coming in is already cold. So we couldn't really measure the drop. We would have to go out to do it. But seeing that the honeycomb pads are wet and the air is flowing good enough, I'm quite confident that it will achieve its expected results.
Excellent, excellent. Thank you a lot.
Thank you, sir.
What is the name of the team again? Sorry.
This is Syntech.
Syntech. Thank you a lot.
Yes. Thank you.
Thank you. Thank you, Team Syntech. All the best. All the best. Chalo. Up next, we have Team Optimizers. So we'll move that side to see the project. Okay, welcome back. Now here we have the team optimizers. So who's going to start speaking? You. Just take a tissue from there. Yeah. So to hold, just to hold the mic. Introduce your team, then introduce the project.
Hi, good morning. Our team is Optimizers. My name is Arjun. And as you can see, he's Lalit, this is Shaheen, and that's Zohaib and Abdullah. So basically, our project is air cooler. So air cooler, it acts like it cools the room. To in our project, it cools it around like 18 degrees. That's the maximum, and the minimum is around 22 degrees. And then the speed of the fan is like 7.6 RPM, like meter per second. And yeah, that's about it. We're using a honeycomb because it's eco-friendly, and then the maintenance is less compared to like other cooling pads. So that's about it. So next Lalit will talk about pots.
Yeah, good morning, everyone. So the major parts of this is a honeycomb and the fan, and then water pump is kept at the bottom, so which will pump the water to the honeycomb, and the water will flow into the honeycomb. And the main use of honeycomb is to reduce to increase the efficiency and durability and reduce the maintenance. So we use the honeycomb for that, and it will take the once the water gets wet, I mean the honeycomb will get wet. It'll take the cool air from the honeycomb, and the heat is extracted, and the cool air is given out. So this is what the inside what we made. So here is what water goes into the honeycomb, and there's a water pump, and this is the fan. So water is coming to the pipe, and then it goes inside the honeycomb, and then the heat is extracted, and the cool air is given out. So this is what our project, and we can control the speed of fan using the regulator. This is a fan speed one. It has from 1 to 5, and yeah, that's it. And it is velocity is something around 7.6 meter per second approximately, the minimum, and it goes up maximum to 10.8. And yes, this is the major working and constructions. Now we'll hand over the error for the error.
So, hi, I'm Shaheen. So, at the beginning, when we constructed this air cooler, we already had an error of water leakage, and we had error of this thing temperature difference. We got temperature difference because of we didn't have a closed lid. We had a lid of only this much. We didn't close it with a cardboard. We just closed it like this. So we had a temperature difference. It was around 22, and it was increasing. So when we placed a cardboard with it, we had a temperature difference starting from 20, minimum of 18 and maximum to 20.9 degrees Celsius. So yeah, we can test now. So right now the temperature is 23 point, now it's 22.9. So you can just check on it. It will start decrease. Yeah, 22.6 degrees Celsius we have right now. It decreases each and every point, and it goes till 18 degrees Celsius. Decreases. And we have the velocity, we have the anemometer, and let me just check. Yeah. So we have the velocity like minimum of 7.6 or 7.4 we'll have. Maximum it goes to 10.1 and 10.5. You can check. See, now it goes to 10.4 and it comes back to 8.5. This is the velocity of the fan. Yeah, that's it. And we had another error that there was a water leakage, and we fixed it by applying this tape, masking tapes and all. So that was an error we faced when we made this project. So yeah, so we'll explain the principle of this air cooler. So mostly we pour water inside of around 4.5 liters, 4.5 liters, and the principle is that the water when you pour it gets evaporated, and the water pump it takes the water through the pipe and it goes to the honeycomb, it goes to the honeycomb and it dissipates the heat from it because it needs heat, so it dissipates heat. And when we switch on this fan, that time we'll get a cool air from it. So that's how it works. This is the principle of the air cooler. Yeah, thank you.
Judges, do we have any questions?
No, I think it's all clear. Thank you.
Yeah, thank you a lot. It is a really amazing experiment over here, and I see you put a lot of effort. Even you get nanometer and the temperature airflow to measure the temperature and to get the exact number. What was the major difficulties you faced in your model here? It was the water leak or something else?
It was the water was leaking the back side where we placed the honeycomb. There was a there was a water leak at the honeycomb and where we placed at the back side. So we need to fix that, and so we had a major difficulty in that, and we fixed it using a tape and the hot glue. That was the major.
Excellent. Do you know what was the budget for the model here? How much the cost?
Yeah, it cost around 50 dirhams.
Excellent.
50 dirhams.
Okay.
50 dirhams. 50.
Okay, excellent. Thank you a lot. Appreciate it. Thank you a lot.
Yeah, thank you so much.
Thank you, team optimizers.
Yeah, thank you.
Take the tissue. Yeah. Thank you, team optimizers. Good luck for your results. It was a good project. Thank you. All right. So right now we are experiencing a overload, not with the projects that our participants made, but our brains and our bodies. So let's take a small break and come back in 15 minutes. So by 11:30 we'll be back in business. See you.
Okay. Thank you a lot. Appreciate it.
With the permission of the judges, can we please showcase the rest of the in-person campus projects?
I think you are muted. I think you are muted. Unmute yourself. I cannot hear you from my end. I don't know the other judge if they can hear.
No, I can't.
Yeah. Yeah, yeah. Yeah, talk now. We can hear you. Yeah, yeah. Go ahead.
Yeah. So
Yes.
our team name is Elite, and we have Asa, Jebin, Saman, and Zeba with us, and myself, Siddharth Nair.
What is the name of your team again?
Siddharth Nair. Team
Okay.
Elite.
Okay, excellent.
Okay. So our project is solar water heater, and the whole objective is to increase the water temperature from from 30 degrees to nearly as to 44 or 45 degrees Celsius. So the project, the structure we have painted it completely black, so it will act as a black body. So we know that the black body it will absorb wavelength of every it will absorb energy of every single wavelength, which will also help us to trap the heat inside the copper coil and right, but which will help us to trap the heat inside the copper coil and to raise the temperature of the water. So should I just show the working? Okay. Yeah, that's what it is. Hmm. Now we'll measure the initial temperature of the reservoir, which is around, once again, it is around 31.6 degrees Celsius right now currently. Yeah, 31.6 degrees Celsius. And now when we turn on the pump, can you just check the temperature of that? Yeah. Oh, wait. We had to we have to keep the water inside for quite a long time because it's a solar water heater and it takes time to increase the temperature of the water. It is actually slowly, very slowly. Yeah. From 31.6 to it has increased to 32.2. Slowly it's increasing.
If she can measure the temperature getting out of the heater itself.
So I didn't get you.
The water getting out of the heater itself, if she can measure the temperature, not the water
Yes, sir.
in the bucket, that
Yes,
will
the
give her
water.
a quick result.
So the water coming out of the heater is right now it is like at 32.6, which was and
Excellent,
the
excellent.
and the
The
water before. Hello. Yeah,
yeah, yeah.
and the water which was there and the water in the reservoir in the bucket, that was
Mm.
around 31.6,
Yeah,
and the water
excellent,
coming out from the heater that has increased to 32.6.
excellent, excellent.
It is slowly rising. The temperature is slowly rising.
Mm-hmm.
So as you can see, it is slowly but surely it is increase. The temperature is increasing. Gradually it increases. Now it is at
Excellent.
32.9.
It will take a few minutes, but eventually.
But yeah, if we keep it for a long time, the water inside the heater under the sun, it will increase to around 44 degrees. We had recorded it yesterday, and while testing it, and it had increased to 44 degrees Celsius.
Excellent, excellent, excellent. Super.
Now, so you can also see that now it has increased to 33 degrees, which was before it was 32.8 to 30.
Mm-hmm.
It was around 32.6 to 32.8. Now it has increased to 33.1.
Great, great.
Yeah, I guess. Yeah, that happens. Yeah, it's many. It will take time to increase even more. Uh, yes. Like, do we have any questions, sir?
No, no, excellent, excellent work, and there are يعني a lot of application for it, especially swimming pool heating. Instead of they are using electrical heater, they can use this for a swimming pool heater
Yes, it is
and a lot of
sustainable,
things.
and we won't be using any like fossil fuels for it to generate electricity. It is completely sustainable.
La, la, great work, great work. And which material you are used to paint it? The black material you said.
So I didn't get you, sir.
What is the black material you use to paint the the heater?
So we have
Or
we have used a normal spray paint, a normal black spray paint, which we get usually in a store. Right?
excellent, excellent. Lala,
So
great,
it will
great.
help. So it will help us make it act like a water, like a black body,
Mhm.
which will absorb.
Absorb more heat. Mhm. La, excellent, excellent. Thank you a lot. Appreciate it.
Thank
Thanks.
you. I don't have any questions, but I just want to say thank you. It's a very good project, and I think we can use it in many applications here in the UAE.
Yes, ma'am. Of course.
Yeah, yeah. Our son is the only thing we can trust.
Yeah.
It will not fail you.
That's the only. That's like mostly free.
Yeah, yeah, and it is always trustable here, so that don't worry. Thank you a lot. Thank you a lot.
Thank you.
Thank you. Thank you, Team Elite. Good luck for your results. Right. So, right. So our crew decided to, after this hot sun, let's go back inside and see a few more projects in a while. Meanwhile, we'll ask few people about the experience regarding the event. So first, we have Anand. Anand, come forward. So I don't want to walk alone inside, so I'm going to take you along with me. Share your experience of the event from the hosting point of view.
Well, till now things were going really great. Like at the starting, we had some difficulties here and there, but then yeah, we managed it like really well. And then like yeah,
He's shy in front of the camera. That's the whole thing. So we have Srijat also, who is the president of Ashrae Students Falcon chapter. So he's going to share his experience and how he managed to put this event. Srijat.
Hello guys. So first thing which I have to tell is doing a project competition online is actually kind of disastrous. But somehow we managed to do all these things, and I really appreciate all the efforts of all the participants and explaining a whole project concept, that too online within the time frame is really hard task. And somehow all the participants managed to do the same. So I really appreciate all the participants and also our beloved judges and chief guests. They just came and they were having a really busy schedule and they took their time to come and spectate the whole event. And I really appreciate that effort. So I guess I will take you to Sai right now. All right, Sai. 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 So we have our HOD here, so you can introduce them.
So come over here. Right. So we have the head of the Department of Mechanical Department over here, Mr. Rajiv Selvam, sir. No.
Yeah, very good morning to all. So I've seen all the projects from first year, second year, third year, and a few projects in final year student as well. So the project, whatever the students they did, it's everything is fine, and also whatever they studied in during their coursework. So basically in mechanical engineering, so whatever the courses they studied, so that they are going to be converted into real-time project. It's a with hands-on experience. So in mechanical, we have in the workshop practice as well as various labs. So they just implemented based on their experience with help of our faculty member, Professor Sambat and Mr. Alvin. So it's a real-time hands-on experience for all the student. So with respect to each courses, so probably this is going to be not only kind of prototype or only designing model, designing of the any projects. So definitely this project is going to be implemented in final year as a main project. So this is going to be the main design and the analysis as well as they are going to do the testing in when they are reaching to final year. So probably most of the projects in third year. So this project is going to be continuing in final year as well. So they will be doing testing and analysis. Then finally it is going to be taken as a benchmarking of the any product with respect to all the projects. Then we'll go for a kind of patent or publishing the papers in future. So thank you once again for organizing this such kind of good event. So all the best, all the very best to all the students. So keep continue these kind of projects. This will enhance your knowledge as well as your practical knowledge. Thank you.
Thank you, sir. Thank you so much for your support, sir. All right. So we'll move on to the next team. We have a team from second years. Who's going to speak from your team?
Okay.
Introduce your team. Introduce your team members.
Well, hello everyone. My name is Vijay, and I'm representing from the chemical year, and this is a project. This is called Air UR. So it basically means air, fresh air. So here are our team members. Please show the camera. She is Krishna, Tamanna, and Sona. So now I'll hand over the mic to Krishnajit so she could explain the rest.
Hi, this our project is Bio Wall, and it has a standing vertical garden. And right now, I'll just hand over the mic to Tamanna to speak about the history.
So this bio wall we could see in earlier times, like in Hanging Gardens of Babylon. So in earlier times also we can see this, but Hanging Gardens of Babylon it was more like roof garden rather than bio wall. But in Scandinavian to Japan, we can see that they used to cover like indoor plants to cover their buildings. So that was that, and later it became known as green facade or bio wall. Now I'll hand over the mic to Sona.
Okay, I'll just do the demonstration of the project. So this is an acrylic sheet based project. I mean, it's made up of the tank is made up of acrylic sheet, and then we have a standing vertical garden over here. And as per the standards, it's like 15 to 16 plants can purify is enough to purify this volume of air. So basically, what we're doing is we have a vertical garden, and this is our irrigation system. The three main parts of a biowall are the irrigation system, the wall, and the vegetation. So here is our vegetation, and this is the irrigation system here, and this is our this is the air duct, which means there is a blower attached to it. The blower will take the air and circulate the air inside this tank, and this tank would purify the air. After purification through this pipe, it would go back to this bucket. And the highlights of this, I would say, are there is less energy needed in the whole system to work, except for a 270 CFM blower, which uses like about 600 to 750 watts. No other energy is required to operate the system. There are biowalls in which there are sensors, automators, automated system, etc. But this is a simple one, and everything is sealed with the use of silicon gel. Right now, everything is completely sealed. So the outcome, the main objective of the biowall is that the air from this, suppose this is a room we are in, the air from this is taken in with the help of a blower and into this room. And from this room, the air gets purified because of the plants and also because of the soil. Like the soil, there are bacteria inside soil, and this bacteria would take up particles like pollutants like formaldehyde and VOC, etc. And it will also, apart from the plants, it would also help us purify the air. And this air through this pipe is let inside this. So it is recirculated back to the room. After each circulation, it's like a continuous cycle of circulations. After each circulation, once the oxygen would become saturated in both these things. But actually, as per the Ashrae standards, a particular level of oxygen, when it becomes more, it is called as hypoxia, which is harmful. But in the case,
We can't hear you anymore.
I think the mic is dismantled. There are no voice anymore.
Yeah, we can't hear anymore. Hello?
I'm sorry, the mic was mute.
Yeah, now it's okay. Go ahead. It is okay now. Go ahead. It was okay.
Should be green, okay?
All right, all right.
We can hear you.
I'm starting.
No, 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 no. Just the last piece. Go ahead. Go ahead. Continue.
Okay.
You reach until saturated
Okay,
oxygen.
so basically what I was explaining is that the it is recirculated, the air is recirculated, and the problem of hypoxia arises once the oxygen and the carbon dioxide levels are it is completely oxygen and there is little or less percentage of carbon dioxide left. But this can be solved in real life scenarios. For example, when we open the door of a room, the oxygen would again go down. So the problem of hypoxia is also a problem of hypoxia is basically solved. And coming to our irrigation system, we have the tank here, and without any automation or anything, the water would go into the plants, drip irrigation kind of thing. Not exactly drip irrigation. We have small holes, so only the water that is to be absorbed by the soil would flow, and there is nothing of leak. As you can see, it's all dry here. There is no leak and the plants are still fresh. And the other thing is that according to our Fusion 360, this is a CAD model. We did it in Fusion 360. According to this, the water is kept in a bench which is approximately two times the height of this vegetation wall. So without, just because of the gravity, the water can fall. I mean, the water can go and reach the plant soil without any actuators. I mean, without any automation system. So yeah, and the other one which I want to mention is the cost of the project is really less. Like we have used we've reused plastic basically, and then we have used plants from our gardens, our balcony gardens, and then again this is a reused product. And then all we have got is the blower and the duct tape. So, and I'll just hand it over to Sona.
Okay, so there are some advantages as Krishna's already mentioned before, but I'll just tell some more. The first one is very obvious, as she has explained. This biowall purifies the air, but not in full efficiency, because if you do it in full efficiency, you will face an issue of hypoxia. That is, the amount of oxygen level will be much higher when compared to carbon dioxide. The second advantage of this one is it reduces the ambient temperature. Now, we know that these plants can they can absorb 50% of sunlight and they reflect back 30% of the sunlight. Because of this, the enclosed space temperature will be reduced by maybe 20 to 25%. And because of that, we would need only 33% less amount of AC air conditioning energy. And because of this, we can save cost. The third one is these this biowall can actually reduce the ambient noise also, because we know that there are plants, in these plants have the soil and water, they have moisture and soil, and we know that moisture and soil, they are these acoustic insulators, so they absorb the sound waves. So whatever place these are kept in, especially closed space, it is more calm and serene, the voice is less, the noise level is comparatively less when compared to the normal ones. And the next one is it reduces uh, it actually increases the fire resistance. So now in case if your place is having fire or something, this one gives a pretty good insulation since it has water content in it. And the next one is, since these already purify the surrounding space, it actually takes out all the dust particles, all the harmful chemicals or that are present because of the paintings that are there on the concrete walls. And because of this, we can avoid conditions like irritated eyes, sneezing, coughing, all those type of allergies that people who have dust allergy faces. And the very last one is it reduces the maintenance cost also when compared to any normal walls, because you have to keep repainting and keep maintaining it to just like have a very good living condition. And the applications of these include there are two main applications. One is for the indoors and one is for the outdoors. For the indoors, we don't need much of these plants because since there's a limitation of the size, like there's a limitation of space, so the plant wall will be kind of less small in size, and because of that it's pretty easier to maintain. And we can use tropical plants here since they have high moisture content, like papaya plant, orchids, everything. And if we are
using these in outdoor spaces, we mainly use it for ambience, just for the looks, because most of the plants, they can't survive the outdoor conditions except for few. So we have to have a really good maintenance so that the plants don't dry out and they don't get ruined. And now I'll hand over to Vijay to give a hand over to Krishna to give a conclusion. Thank you, Sona. I request the host to kindly allow us to share the screen. We just want to demonstrate our experimental results. As I've told, this is completely sealed with silicon air, which means no air from outside other than from this room would go in. So we just want to demonstrate a video, demonstrate with the help of a video that we have taken earlier. Can the host please allow us to screen share? Niti Sai Vijay.
Judges, sorry for the inconvenience. The participants are trying to share their screen to explain the concept better. So please do excuse the delay. Thank you.
Okay, sorry judges for the delay. Sorry a lot. Okay, so basically uh, this is the, the device which we use to measure. So it measures the carbon dioxide, the total volatile organic compound, and the formaldehyde levels in a room. So it was found to be. Judges, are you able to view the screen?
Yes, yes, we can see
All
it.
right, all right.
You can't see the video, or did you start playing the video?
Okay, so it goes above. As we can see, there is pollution alert. Pollution alert is there with the sad emoji. So as per the standards, as per various standards, about 900 and about 900 to 1000 is considered as pollution levels, and as well as the total volatile organic compounds and the formaldehyde levels have also increased. This I've taken it yesterday, right from the room right from the room we have set up it. I mean, it's outside our bio. And the next video,
I couldn't see the video. It
could you
wasn't.
please?
Hello.
Is it shared now?
I can see your window, the screen. I can see the window that shows 3 videos, but I wasn't able to see the actual video.
I showed in my.
Sorry,
I
ma'am.
think
We will try to reshare the whole screen.
I think she's sharing one screen and not the other. She have two screens.
All right.
Just
All right.
she need to press that is to share the other screen.
Sure, sure, sir. I will see to it. Sir, are you able to see the screen right now?
Yeah, now it's okay.
All right, Krishna, you can
Okay,
continue.
so we have measured with this instrument, and as you can clearly see, right outside the setup yesterday when we took the video, the CO2 part ppm is 982, which is about the standards, about the various standards requirement. It has exceeded, so hence it is showing as pollution. And then the total volatile organic compounds and the formaldehyde levels are also high, hence it's shown as pollution. This was taken right in the same room as the setup is built in. And the next video, the next video before the next video was taken. This is inside the biowall, and as you can see it is carbon dioxide levels are around 397 ppm. The total volatile organic compounds are 0.010, and the formaldehyde levels are also very low, and hence it is shown as no pollution and good environment. The environment would be excellent inside the biowall. Okay, so that's it. Thank you so much, and sorry for the inconvenience speech. Do you have any doubts, judges?
Sorry, I didn't quite get where the instrument that you used to measure, where was it placed or where was it fixed in the second video?
So basically, the instrument yesterday was kept outside the room and taken. The measurements were taken, which indicated that the air quality level was low and there was pollution in the environment. And at the same time, after we have switched on the blower and after the device was actually operating, and after like 2 to 3 hours after operation, the measurement device was kept inside and the device was kept operating for 3 hours, and then when we measured, it showed 380 or 395. That was the carbon dioxide level measured.
Okay, thanks.
As for the video, I hope you have seen the video.
I did, but it's okay, I get it. Thank you.
All right.
Thank you so much. It's great.
Thank you.
Thank you a lot. Really amazing work, and you've done a great job over here, Yani, with this perfect experiment for the air quality over here. Do you have a budget cost for the whole system? You've done it here?
Yes. The budget cost is like about 280. So basically, what the things that we had to buy is the acrylic sheet and the duct and then the pipe and the blower, around 200, 250. And the others used are completely reused. So, and the plants, the main thing in the system, the plants, those were taken from our garden and then they grew. And the other one was in bottles. Plants are kept inside bottles. Those are also used. Again, this is also reused bottle. The cost was not so much. It was just around 200, 250, 80.
Excellent. Thank you a lot. Appreciate it. Thank you.
Very creative.
It's
Thank you
very
so
cost efficient method which we can set it up in our houses, like a DIY project. Need not use all the sensors or any kind of automation system. Just we need is a pump. Just we need is a 600-watt blower. And thing is that if the formaldehyde and or other pollutants are absorbed, the pollutants that cause cancer and certain other forms of leukemia, those are absorbed, then you wouldn't get the disease, and basically you wouldn't have to spend that much hospital bills. So this, I would say, just the blower is operated. So it is a 600-watt blower is operated 270 CFM. So it's really cost efficient option.
Thank you so much.
Any other questions, judges?
No, thank you a lot. Appreciate it.
Thank
Judges, any other questions?
Much. No, that's a very creative project, and thank you for sharing it with us. No questions.
I'm sorry, I'm not able to hear anything.
Thank you a lot.
No question. Thank you.
Okay, thank you so much. Thank you so much. Sorry for the delay.
Thank you, team. That was a good project. Good luck for your results. Okay, so let's move on to the next project. Judges, just a small note that one of the team has just registered. So they are called Team Cooling Rig. So please make note of that. So this is Team Cooling Rig. Come. So these are the final year students who are presenting their final year project over here. So, Mehak, yeah, please take off the mic. Introduce your team and explain about your project.
Hi, so we are Team Cool Rig, and this is our cooling tower test rig. So this is our project basically, and what we do is we're trying to simulate hot water, which is being cold. So what is happening is this is like it works somewhat like a principle to a counterflow heat exchanger. So the water is going in counterflow to the airflow. So you can see inside. Um, so you can see that there's a water flow and the water flows into a packing material. So this is an example of this packing material. So the packing used is for providing maximum cross sectional area. So there's more space for the water and air to interact within the packing. So there's a packing which is placed, and there's an exhaust on one side and there's a blower. So what happens is the air flows upwards. You can feel the air here, but the air flows upward and the hot water comes from the top and gets collected in this collector tank, and the exhaust makes the whole thing, the exhaust and blower system hold together makes it like a forced convection sort of system. And we have valves for controlling the flow of the water, so we can check the temperature drop from the water in the tank to the water below, as well as we can check the rate of convection that is happening without the blower because of normal interaction. If we just leave the door open and see how it works as natural convection and forced convection with the blower and fan as well. And we can also check the quality of the air, and we can regulate the different flow rates of the air and water to check how each of them affects all the different cooling properties of the water and the system as a whole. That's it.
Thank you. That was a great presentation. Judges, do we have any questions?
I am okay. They are the final year, yeah? Hello? Can you hear me? Yeah, I think they have.
Final year students, yes, they mentioned that in the beginning. So I think this is their graduation project.
Okay.
Sorry, just a second. We cannot hear the.
You cannot hear us, yeah? You
Oh,
cannot hear
we can
us.
hear it from there. Okay. Listen. Yes, sir.
Yeah.
Yes, judges. We can hear you now.
Yeah, thank you first. Really amazing project. Did you get any data from it? Did you make any log for the temperature?
Yeah, so
in,
we
out?
had a
Yeah.
small issue with that because the submergible coil that we have got for the hot water tank, that is of more than like 2000 watts. So we're not able to plug it in the lab that we have here because the circuit will trip. So the water is not that hot. So the data is like very little. There's like only 4 or 5 degree temperature drop from what we use. So we use like temporary. We use like a kettle to heat the water and attempt at seeing how much cooling would happen. But then the water was not hot enough to see like a lot of temperature drop. So far it's like 4 to 5 degrees difference with like 35 degrees Celsius to 30 degrees like that.
Excellent. Thank you a lot. Thank you. Appreciate it.
Is there any other questions?
No, that's it. No more questions. Thank you. Good luck. Can you hear us?
Uh, I, Yeah, tell me.
Oh, I was saying that's it. Thank you. No more questions.
Oh, okay. Thank you.
For the presentation and good luck.
You guys are ready, no? Have a team Robotech. So let's start with them. Sure. Good morning, fresh faces. Okay, so let's start with your team. First, introduce your team members and start your project. Okay, good luck.
So, hi, my name is Ryan, and our project is an AC. Okay, it's a two-in-one. It's an AC and a humidifier. So let me first introduce my team members. Start off with Sherwin, Farooq, Vincent, and Sarah. Our project's name is Winter Breeze. It's a two-in-one. It's a humidifier and an AC, as I had mentioned it before. So let me tell you a little about the working. So we have a water reservoir with ice cold water. We have ice added to it as well, ice cold water in it. So now this ice cold water is being pumped out of the water reservoir by an aquarium pump that's inside, essentially 25 watts. And it gets pumped into the radiator, which is inside. So the explanation about the working of the radiator inside our insulated box will be explained more by my fellow teammate, Farooq.
Yeah, so basically the water or the cold water from the pump is pumped by the pumps into the radiator coil. So the radiator coil is basically working on the radiator principle, that is to radiate the temperature of the fluid which is flowing through it. So in this case we are using a cool fluid, so the temperature is gradually dropping inside and simultaneously the blower is blowing air on the radiator coils. So the cold air is building up inside and the radiator is radiating that coolness of that water. So the building up air is then escaping from this vent which we have created, and we can notice a significant drop in the temperature. And
our box is made in such a way that there cannot be any leakage of air from this box. This is called insulation box. The air that is blown from the blower will circulate within the insulation box, and then it will circulate within the insulation box, and this will cool the air within, and there will be a significant temperature drop, and the air will be pushed out of the outlet in a much force. As you can see, there's a radiator coil inside, which is when the air circulates within the box, it touches with the cool air and it cools down the air within the box, which is pushed out from the outlet, which gives out a cool air over here. That's, yeah, this is a 2D model of our diagram, where the yeah the water from the water reservoir from this from our cold storage box is pushed out to the pump, and it goes into a radiator coil, where the blower or with this cool air will get a hit from the blower, which creates a which cools down the temperature within the box, and then the water runs back into the box, and it goes back into the cold storage box, which helps us with this process circulates throughout. And when the blower hits the radiator, this cool air will get pushed out through the outlet.
temperature we have noted.
Okay, so let me tell you something more about our testing. So now I'll show you how the temperature difference of our AC. So initially, yesterday, we did a testing, and we'll show you a live testing as well. Yesterday's testing, we saw that before we started our AC, we had a 24 degrees initial room temperature. And then using the AC after 15 minutes, we had an increase of humidity and temperature drop. So we had a 5 degrees temperature drop, as you can see. 24 degrees Celsius was the start, and after 15 minutes we had a 19.6 degrees difference. So a 19.6 degrees it dropped to. So right now, again we started at 25.1 degrees, and now if you go to see, we have 19.7. It's dropped down to 19.7 from 24.1. And even the humidity, you would have seen it has increased to 64 from 59. Essentially, our project can work on solar, as mentioned before, with a power inverter and solar, and this is pretty. It's pretty convenient, and it can move. So it's pretty. We can carry it in cars for picnics, for our overnight stays, etc. So the culmination, I'd like to hand it over to Farooq again.
Yeah, so in most of our regular air conditioning systems, the most problem is with that is the emissions from the coolants. Nowadays, we are getting newer coolants which have less emissions and negligible emissions, but then also the danger comes out with that poisonous and flammable nature. And this, our project is significantly cooling down at not as significantly as a regular air conditioning system, but then it has an advantage of that it's completely portable, so that it can be taken out anywhere, any place, making our project completely reliable. So that's all. Any questions?
Yes. What is the challenge face you in creating this model? Can you hear me first?
So the basically the challenge was to assemble these parts like the radiator coil and all. So the yeah.
So essentially, the issues and challenges we faced was initially we were searching for a radiator. To our advantage, we found a radiator from a workshop. So we bought it for time being to use it in our project, and the thermocol was supplied. The thermocol was easily available that way. Insulation was also an issue since the thermocol was porous, so we had air escaping from many areas. Therefore, we had to insulate it well, and we used epoxy in few places to seal it up. Other than that, we had another challenge we faced was we tested this out with a solar panel and a power inverter, but we were unable to get it today. But yes, essentially we have tested it out and it does work on solar. Other challenge
Uh-huh.
faced was getting a water tank, having a proper hole for the pipe to the radiator.
Okay, okay, okay. Great, great. Thank you a lot. Appreciate it. Thank you a lot.
Thank you so much.
Any other questions from judges?
No, thank you. Good job.
Thank you, ma'am. Okay, good luck, Robotics. It was a fantastic project. Thank you. See you. Up next, we have Hack Breakers from first year as well. So, one of you come forward. Please take over the mic. Introduce yourself and then introduce your
My
team.
name is Aldred, and this is my team Hackbreakers. What we've built here is a humidifier that can emit dense vapors from water molecules, sensing the humidity around it. And it is automated by Arduino. Here, the Arduino we have right here.
So basically, we have used really basic instruments for this project. We've used an inductor, then around how many? 120 microhenry. We've used two capacitors of about 100 nanofarad and one capacitor of 10 nanofarad, and one IRF Z44 MOSFET, and one NIC NE555 timer, then one variable resistor of 10 kilo ohms, then a piezoelectric disc, and a temperature sensor, DHT 11 temperature and humidity sensor.
So the connection basically is it's a circuit board we are using which is connected with a variable resistor of 10k ohms, which can be varied to 5k ohm as well. And there is an NE555 timer which allows us to set the required voltage in the time required. There is a transistor which enhances the voltage given in, and we've used a resistor as well, which gives a required amount of voltage passing through the circuit. And it's all connected to the breadboard, which is connected to the DHT11 humidifier, and then it is connected to the Arduino Uno. Um, and now,
Okay, so how this works? So this is a piezoelectric disc. This provides the vibration required to create the splashes. So once we hit 113 kilohertz in this tiny disc, it vibrates at a certain speed, which produces like really tiny particles of water. That is, in the form of mist. So that's how it produces a mist. So yeah, that's how it works.
there is a circuit diagram on how the circuit actually works.
Hi, we can't hear you anymore. Hello.
I think you have a problem with the mic. It is muted again. We cannot hear you. We cannot hear you. Yes, now okay. Now okay.
Any questions, sir?
Yeah, can you repeat your part? Because your part, it was muted, the mic.
Oh, okay, sir. One of the main components of this experiment of ours is the piezoelectric disc, as we needed to vibrate at a certain frequency of about 113 kilohertz. So unless it vibrates at that frequency, we might not be able to actually see the mist, and the mist formation might actually not take place. So, yeah, yes, sir.
Yes. First of all, nice experiment. And how much was the budget for the whole component here, and from where you get it?
Sir,
We can hear
the
you. We can hear
budget
you.
was for the circuit. It was approximately around 50 dirhams, and except the Arduino, which was we already had the Arduino Uno. So
Mhm.
yeah.
Arduino is cost you a little bit more. Okay. Okay. Excellent. Thank you a lot.
Thank you so much.
Thank you, judges. All right. Now we have to move from one lab to other to see the next project. So we will be back in 30 seconds. See you. Okay, welcome back. Now we are with the team Hydromech. So I'll be handing over to them. So they'll start the PPT. First, introduce your team, then start your project. Thank you.
Good afternoon, professors and judges. I hope you're well this afternoon. Our team is called Hydromech, and our whole project revolves around hydroelectricity.
and we'll also be using and explaining how Pelton wheels work. Um, so so basically, Pelton wheels, what they do is it's in the form it's in a cup shape, and it uses the impulse of the energy that the water produces rather than the dead weight of the water, which is used in traditional water turbines, and which makes it more efficient than the normal traditional ones. The working principle is just that the water force turns the turbine wheel, which is connected to the DC generator with the help of a shaft, and which converts mechanical to electrical energy.
So one of the advantages of using our system is that it uses a clean energy source, which achieves the sustainable development goal of clean energy. And around 1.3 billion people around the world still do not have a clean energy source. So implementing a hydroelectric power plant will be affordable and more reliable to the general public. Some other advantages of using our system is that it's a clean energy source, and then it's sorry, it's domestically component, which means that it doesn't need international resources or other help, and it is self-sufficient. It's also one of the most used renewable energies around the world as of now. Now we'll move on to the working.
So basically, it's very simple. The water falls onto the Pelton cup, so the weight of the water forces the Pelton wheel to rotate. So the weight of the water forces the Pelton wheel to rotate, which in turns rotate the electromagnets which is inside the DC motor, which is connected via shaft. So basically, it turns mechanical force into electrical force through the principle of electromagnetic induction.
So we'll switch on the water pump, and so that the you can see the light bulb light up. The bulb is switched on, as you can see. If it's not visible, we have a video as well for you to see the working and the. Can we switch it up? Yeah, let's switch it up. So this is how we. If you can just, this is the working process while we were making it. So this is just to see if the turbine works, the turning. And when we first tried it, the light was really dim, but now it's. If you go to the next slide. This was in the morning today, and you can see a more brighter light than compared to before. Yeah. So
Alright, so this is technically. Alright, so this is the drawings. This is the drawing sketch of our Pelton wheel, and we use the area of 127 square millimeters, and the flywheel of 50 millimeter in diameter, and the length of the rod around being 120 millimeters long.
So when you have a specific goal or a motto, we obviously have real life implementation and real life applications as well. And one of the main criteria required for hydroelectric power plants is that it requires a source of water, and it can be in the form of a river or a lake, or it can be reservoirs as well, which we use as dams. In case worst case scenario, if you don't have a specific source of water, you can always there's in the Imperial Dam in the US, they use a specific river, which they use canals to which transfers water from one place to another where electricity is generated. Right now, China is the largest producer of hydroelectricity in the Three Gorges Dam, which is there, which holds back the Yangtze River, and it produces almost 22,500 megavolts of electricity. In our home country, India, we have got around 197 um, hydropower plants, which produce around 22. Sorry, let me just check. 25 megawatts of water. Sorry, of electricity. Wait.
So there are many reasons why our project hydroelectricity can be used over other renewable resources. Like wind energy, it takes up a lot of space, which reduces local bird population, and it also causes local disturbances of people. And whereas solar energy only works best when the sun is at its peak, and it has very high implementation costs. And even biofuel energy resources, they require only a certain crop to be grown at a particular time, and it also increases the carbon footprint, which is bad for climate change. And whereas nuclear energy can also has a very high maintenance cost in case of any catastrophic disasters that may occur. Next, we have our costing. Our project that we used to build cost around up to $117, whereas an approximate of a large scale project would come around $1,500 to $2,000. Thank you.
So this is our team.
Yeah, that's our team. And yeah, thank you.
Do you have? Sir, do you have any questions?
Thank you so much. I think it's all clear for me, but that was great. Thanks so much.
Thank you. Thank you very much. Have a great day.
Thank you. Thank you. Appreciate it. Thank you a lot.
Bye.
Great work.
Thank you very much. Thank you so much. Oh, sorry. Thank you.
So, congratulations, Hydromic. It was a great presentation from the first years. Good luck for your results. Thank you. So, we'll move on to the next lab now. So, before that, we'll take a 30 seconds break. All right, we are back with the next team here with me. So, excuse me.
Yeah.
Take the mic. Introduce yourself. Take your team name.
Yep.
And then start with your project.
Hi, we're Chomstuck. Oh wait, sorry, yeah, we're hold. Oh, okay, never mind.
What you guys can do is like you all move out so that you can remove the mask and you can speak properly. Okay.
It's a clever idea. I like it.
Because you all just move out, like just stay one or two people. That's it.
It's a
That way it
brilliant
will be safe
idea.
also, and no one will question you also.
It's a brilliant idea.
Right?
Okay.
No, it's like you hold the laptop itself in your hand,
Exactly.
or you keep it over here and hold the mic. You will be from a distance, and you all move out. So then you can remove the mask and you can speak properly. Right? Could be feasible.
Hello, hi everyone. We're from Chomstuck. We're just five guys who decided to try something interesting and new, and hopefully it's fun. That's it? Is it good? Yeah. Okay, so we made a JCB crane using a hydraulic system using pneumatic tubes and syringes to operate this system. It works by the process of pressurizing the fluid that remains within these tubes and syringes to essentially move and operate the mechanism. The pressure is maintained by the suction of these injectors, and the tube itself is sealed with glue and extra stuff so that we don't. Yeah, so we'll show it to you guys, I guess. We need more pressure. That's okay. Yep, that's it. So yeah, is there anything else you want us to tell you? Judges, any questions? Oh, does the judges have any questions? Feel free to ask because I know what I'm doing.
Thank you a lot. Appreciate it. Nice idea, nice mechanism of working.
Thank you.
Thank you a lot. Appreciate it.
Thank you. No question. Wow.
So, is that
No
it?
questions.
Yes.
Take the tissue.
Oh, yeah.
Yeah. Thank you, judges. Now we have the final project presentation over here from Team Mrunal. Mrunal itself is presenting.
Yep. Yeah. Good afternoon, everyone. My project is based on copper condensing system. So basically, yeah, my project is based on copper condensing system. In this system, you can see a small water reservoir in which I've kept the water as a medium of cooling, as a refrigerant, and the coil. Can you please project on this? And the coil which is kept near this are the copper cooling coils, which will condenser, which will cool down the water, which will circulate to this copper. Okay, and when the cold water is being circulated from these copper tubes, we will get more cooler air as in return. We could say almost 7 to 8 degrees drop we can get efficiently if we can manage in a adiabatic system. But sir, since and ma'am, I wanted to show you the whole components, I kept it open, and the reservoir which I kept it outside is to excess of any water content, if in case we have. And this system is basically based on the principle of convection, in which copper tubes will help cool down the air, and this behind which we see is the VCR system which will be in use. Yeah, that's it. Yeah. I would like to end this my presentation with a short note that my friend Srijit Sanal Kumar helped and guided me with this project. So special credit goes to him as well. Yeah. Any questions, sir, ma'am?
Thank you a lot. But just in the backside is the condenser. It is for cooling. Can you just explain the backside a little bit?
Yes, sir. So this is basically my VCR system, and I have set up. This is whole is the VCR system, which I have set it up in a motor, and the fan is being circulated. And in front of that, we got copper tubes, which will uh, help cool down the system.
Okay.
Yes, sir.
Okay. Thank you a lot. No further question from me.
Okay. Thank you, sir.
All right, that was the last presentation for today. I'm Sai Rohit Behera. Along with me, I have Fabian and Mevin, who, through his camera lens only, you are watching the whole event. So that's it from our side. Sign
Thank you
off.
a lot. Thank you a lot. Thank you a lot.
We'll
And
take
thank
a
you. Thank you for the
Thank you, sir.
thanks for the guy who holding the computer all these times. If he done a great work. Thank you a lot. Appreciate it.
Thank you, sir. Thank you very much.
So I request Nafisa to take over the event, and we will join back soon.
we are now in the final segment, which is the results time. There is a little special announcement, which is we have few special awards for all the first year students who took part despite all the restrictions. I'd like to welcome the judges to give a few words of wisdom and share the results. Thank you.
You are mute, Minna.
Oh, sorry. Nafisa, are you here? Anyone? Srijit? Anyone from the
Yes, ma'am. Yeah, we can hear, ma'am.
So are we going to take some time first to finalize our results and then we'll talk about them?
Yes, I agree. Also, can we have 5-minute break or something like that?
Judges, we will be having a quick 5 to 10 minutes break. We will be back after that. Thank you.
Thank you.
Meanwhile, we are taking few interviews from the hosting department, so other people can stay online. All right, welcome back to post-match interviews. So we got Krishna with us, who has just presented her project. So we're gonna take her interview. Krishna, this was your first virtual event, right? Virtual project event, right?
Hi, this is Krishna Ajit here. I'm currently the head of promotions for Team Ashrae Manipal Dubai, and I've joined Ashrae in 2019 November, and ever since it was really nice journey. Like joining in Team Ashrae helped me identify what I am good at. Before, I didn't know I was good at promotions. I didn't know I was good at handling social media, and I didn't know I was good at HVAC field. And all this after joining Ashrae, I got a really good experience. I had really good guides like my professor Sampath Suranjan and the other teammates who were very cooperative. And it helped me know my strengths and where I'm weak at, my weaknesses, and then it helped me improve a lot. And today had first virtual project competition event, and this I would tell that personally from my side virtual events were really boring, but this idea of having a field host and it actually it was not at all boring. I would tell it was not at all boring. It was a really good event. And thank you. I'll hand it over to Sai.
Thank you, Krishna, for your time. So let's wait for the results and see what happens. All right, thank you. Up next, we have Fabin. Up next, we have Fabin over here. Fabin, come on. So me and Fabin were the hosts today on the field. So Fabin was holding a laptop and I was hosting the whole event. Fabin, my first big question, how was your back?
Yeah, it was hurting.
Is it terrible?
It's not terrible, but yeah,
But it's hurting.
it's hurting.
So after a long time, we have been experiencing back pains, just because you are standing for a long time, and we are just 20 years old, both of us.
No, no, don't worry, don't worry. You need some exercise.
It's an exercise. During the lockdown, we were used to like
To relax a
stretch
lot.
our backs all the time.
No, no,
And
thank you.
thank
Thank
you,
you.
sir.
And him, he make a lot of effort, yani, holding this computer all this round in the
Thank
sun
you.
and here. It was really amazing work. Thank you both a lot. It was magnificent, and actually the competition was amazing. Yani, the whole experiment and the different grades, they done a great job really to achieve this result. Very, very high standard. Thank you a lot. Sorry for interrupt.
No, sir. Thank you so much, sir. Thank you so much. So we're gonna have few faculty interviews now. Fabin, back to our jobs. Carry the laptop. I'll carry the mic. Just information. So, so we have one more student participant over here for the interview. So we'll take a brief interview of them and then move to the faculty as the faculty is looking at the projects right now.
Let's go sit over there.
Vijay,
Yeah.
so what do you think about the event?
Well, as long as everyone are learning something, it's always a success. So I feel that whoever participating and whoever watching in the Zoom meeting right now, that I guess everyone are learning something. So definitely this is a good success, and I hope that everyone will learn something or the other from whatever they've seen.
So Vijay, you're in your second year right now.
Yeah.
So how does it feel like facing this big challenge at a very younger stage? Because we had these challenges when we are in third years and fourth years. But
Okay.
you guys, it's your second year.
Okay.
With the limited engineering knowledge what you have, how do you build your projects?
Well, that's a tricky one, but in our second years, like in the first years itself, we have faced a little bit, like we had some experience and all. And coming to second year, we all were kind of, we all gathered information. We were interested. The main source of experience is interest. So whatever we were learning and all, uh, we were just learning and we were just presenting whatever we learned. So we didn't see this as a challenge. We just saw this as an opportunity to learn and showcase what all exists really. So there are many things which exist and we don't know much. So as for the development of the technology and everything, we just did a small part from our side.
That was great talking to you, Vijay.
Thank you.
I really adore your thinking. Hope you continue the same. Sure. Okay, now we'll move on to the architects of our students' development. Right now we have all the faculties together. So we'll start over here. Yes, sir. It's been a long time since I saw you. So we are here to take your interview, sir, regarding the event since you saw all the projects right now. So what do you think about the project, sir?
Very first thing is, whenever any such events are made, in fact, it is for failing. Always ask, right, whether you want to fail or pass. So here, everybody attempted to fail. Fail means first attempt in learning, and then only they can pass. So this is really good that they are attempting to learn the things, whatever theoretical things are there, they are bringing into practice, and then here by knowing that others are also doing the competition among them, so they not only do their own work, but they also understand others also. Now, for example, this is one project. They are able to generate 4 volt. They understood the working basic principle. Now, how to enhance, how to make it more better, that can be done. There are some other. So, all are trying to save some energy. Correct. These all projects are saving the energy, are using the natural resources properly, effectively, and converting one form to another. That is a natural, phenomenon. You cannot create any energy, you cannot destroy any energy. You can convert only one form to another. So this kind of competitions, they understand the actual natural law. So how to convert one kind to another kind of energy, and then they understand nature is there already. So many things are existing. We are not able to mimic that, and such kind of competition, I think, should be held more, and students should take more actively participate. They should not be brought, I thought, forcefully brought it here. So, as per the feedback, you can see, yeah, it is a very good learning for them, and for us also it's encouraging, because students are, at least instead of sleeping at home and then wasting time, they are indulged here actively to do something, to learn something. So it's good, very good.
Thank you so much for your feedback, sir. Farzin sir, you're one of the professors who always innovation, or you push students towards good things, like you did for me. So, what do you have to say about the project?
No, from what I've seen so far is as what Ravisha was saying, conversion of the main issue over here. What we are trying to solve is about saving energy, or making the best use of energy. You can put it that way. So there are quite a lot of interesting projects over here. Of course, some are not up to the optimum level or something, but as some suggested, for a starting perspective, of course, it's going to give a great understanding about how things work, and relating the theoretical whatever you have studied on about say thermodynamics or different subjects whatever you have studied. You're seeing it practically how it is affecting. Probably now, for example, in this itself, you're talking about vertical turbines. How just probably the profile of the blade itself is going to improve your efficiency. So all this kind of understanding is going to improve a student's knowledge, and I got to know that it's done by computer science engineering first year students. That's something more interesting. How even they're also interested towards conserving energy and improving the energy source. So if I were to say something, it's very interesting for me, and even I also got to learn so many things. Okay, and probably the senior students, what I would just recommend is that from whatever they have done so far, which is amazing, they can also look into the actual use cases, because the technology could create a huge impact in UAE as well. So, for example, I think the cooling tower, yeah, the cooling tower could be used in. I was just suggesting the participant that could be used in for greenhouses, the greenhouse farms. So they could use in such kind of scenarios where such kind of process really goes on. So they can use they can take the real cases. The senior students can take up real cases and work upon that, which would directly impact the society. Okay, and as junior students, for them, yes, it's a learning platform. It's amazing. Anyways, one more interesting fact is that during the pandemic, I never expected that students would be actively involved and they would come up with a practical, physical working model. So that was something very interesting to know. What most of the students don't want to come to the campus; they want to they want to just stay home. So from there, they're working more and they're coming up with a physical model. That's something which is very interesting to know, especially during this time. And yeah, so that's pretty much from my side. I hope Ashrae has been very actively participating in be it projects, be it funding, be it paperwork. There's very active community over here in Mahi, Dubai. I hope you guys do very well. Okay, and bring more accolades to the university.
Thank you so much, sir. Thank you so much for your support. All right. We'll check with Srijit to find out the results. Until then, you handle for a minute. I'll hold the camera. Check. What you just want to hold the laptop? All right, we have one senior student with us, Mehak. Could you please come forward for a minute? So throughout the event, we have only one student from the final year, from the fourth year, who's Mehak. So she'll be sharing her experience, and she was presenting her final year project. So she'll be talking about that.
So the whole thing was a great learning curve. I mean, when you're in your final year, your project is really important to you. So the whole thing being put together and building it like for the exhibition as well. I mean, it was altogether a great experience, and we learned a lot, and we discovered a lot of faults, and we fixed them, and basically it was a learning curve as
Thank you so much for your time, Mehak. Now, since we have some more time, someone wants to take my interview. I'm honored.
All right, Sarohit, our Chief Operating Officer, was a field host of today. And how do you tell you? Please narrate your experience about Ashrae and about the event. Over to you, Sarohit.
Okay, so coming to Ashrae, firstly, I joined in my second year. So when I joined in my second year, I had no idea about HVAC. I'm actually feeling jealous of you people because you guys get a lot of exposure in your second years. We were not like that. We started slow, but however, we caught up. We learned a lot. I know how these HVAC things work right now. That was not the case before, and I'm sure that it won't be the case if I didn't join Ashray. I wouldn't learn. I wouldn't explore thermal field because I was more into design. So it was a great experience. Talking about the design part, sorry, talking about the hosting part. Well, I thank Sampath sir for trusting me for the first time during July event, for trusting me to host the event. And since that time, I was like part of every Ashray event. They gave me a host position. I was happy for that. So this is my final year. So this is officially my final event in throughout Manipal, and I'm happy that it went great. Thank you.
Thank you so much, Sarohit, for narrating your wonderful
Bye.
experience with Ashray.
I said we will miss you as the host.
See you, man. Thank you.
Next year you will be a full member then. We are waiting you in the other side.
All right, all right. Hello. So from morning 9 a.m. till this time, I know it's been so tiring. So we shall just take a short break. Thank you.
How long is the break?
All right, so we are here for one more interview before our results come out. We're just building curiosity so that you people stay in the call without leaving. So we have one more professor from our university.
I really felt good because I mean most of the things are from mechanical domain and all, and I'm from electronics, so I might have studied it, but I've long been forgotten on all those things. But it's good to see like people from mechanical, mechatronics, computer science, and other departments also, not only on the final year perspective, but from the juniors years also they have participated in it. It's really a good opportunity to showcase like whatever you're studying in theory in a practical format, like it's actually happening. Over here, if you're achieving a temperature difference of 3 degrees or 4 degrees even, that's also a significant milestone for now, because at least you can be able to prove your concept. Tomorrow, if you go for a full-fledged kind of an device or a full-fledged prototype. You might be working in a better format in that way and get a good result in that case. So it's really a good thing. And I also learned many other things, like not only the material part, but itself on the part of like what are the standards need to be followed, what are the regulations are there, what are the pollution standards are there, government regulations, and what could be the size, what could be the material to be taken up, which normally we don't think. When we eventually when we buy an AC, I buy for a cheaper price for an aluminum one, but why should we buy a copper one? Those kind of things, it gives a triggering kind of a thing. Yeah, this is the reason we should buy this one, not the other one. So eventually, it's been a good session for me, basically. Thank you, guys.
Thank you so much. Sir. Thank you so much for your time. All right, so we are up for results. Let's take a small minute and announce the results. All right, so one more person before we close off. You see many projects. This territory belongs to one man over here. That's Alvin, sir. So we're gonna have two words from Alvin, sir. Sir, you're like one of the biggest architect for all these projects, sir. Your support has been very kind to all the junior students as well. So what do you have to say, sir?
That is my duty. I am doing my duty. That's all.
So,
Okay,
yes.
students are coming. I am happy to always work with them.
Yes.
Whatever I know, I want to give them. That's all.
So you've been a great support, sir. Thank you so much for your time. Even when you're busy, you give time to students. I've seen that. I've experienced that. So thank you so much for that, sir.
Thank you almost. So this all is like very important for the students to learn because one problem is that practical having double value of the theory. So if they are doing, they will learn more and more. So only theory is not sufficient. So that's why I am just giving suggestion to all the students to more and more they have to participate in this type of events.
Thank you so much, sir. Thank you so much, sir. So that's it from our side. We'll be back with results. Stay tuned.
Welcome back, everyone. Now, I would like to welcome the judges to give a few words of wisdom and to share the results amongst us. Thank you.
Thank you, Nafisa. Really, it was amazing competitions. All the team was really in a very high standard and in very high knowledge, and all the mixture, even year one, year two, year three, year four, everyone show his competence and show his technical evidence of what they get from all of there. And in the meanwhile, I want to thank the online team. Really, many teams online, they show a very great, even due to the distance, they couldn't compete in a place, and they didn't able to come here. But we promise when this is all over, that is all the team will be in the same place and we can have all their voice together. But I would like also to thank the online team from abroad who wish to compete with us over here. And thank you, Manipal University professors and teachers for the guidance and for your support for this chapter. Who they make a great work over here in this competition. Now I will give the mic for Minna for a few words as well.
Hi. So first of all, I want to say thank you so much to the organizing team and to the students. I honestly have no words other than you amaze us every single time. I say this every single time, and I will say it again. Like the projects that you present to us are beyond amazing. Really, like it was such a tight competition. It was so difficult to choose a winner because they're all amazing. And a special thank you to the first year students. Honestly, I have no words. Like you, I don't want to say you amazed me because that's a very small word for how I felt when I found out that some of you were first year students. It's beyond amazing, and thank you so much. And I say this every time, and I will say it again, that if you continue with this energy, your enthusiasm, your energy, you'll do great things in life. It's beyond amazing, really. Thank you so much. And it's so refreshing to see such young students be so dedicated. Like in your first year, I think back, I was a student not so long ago, and I think back to how everyone around me was, and I don't think I've seen people that were this dedicated from the day one, from their very first year. So thank you so much. Really, it's amazing, and it was so difficult to pick a winner. All the results were very close. So basically, I'm trying to say, I know they always say this, but really, this time the results were very close. You're actually all winners. Thank you so much. So should I announce?
I would like to request the judges to announce the winners now, please. Thank you.
Okay. Should I go?
Yeah, go ahead, Minna. It is yours.
All right. So I'm going to start with the third place. Yes, they are the third place, not first, but a special thank you to them because they are first-year students. So it's very, very impressive that they made it to the top 3. And they are Hydromech. Thank you so much, Hydromech. Your project was very creative. It was amazing. And the fact that you're first-year students is honestly, to me, it's beyond amazing. Thank you so much. And congratulations. Hydromech, is anyone here? Okay, I don't think anyone's here, but thank you, Hydromech. I'm gonna move on to second place. Second place, this was also a wonderful project, and I loved the most about it that it was done with very minimal resources. Like they didn't spend so much, as they already told us. They got the plant from their garden, and they used a lot of reusable resources. And yet their project was amazing and very creative. This is in second place is Air Your. Thank you so much, Air Your. I don't know if anyone's here, but your project was amazing and you're great. So thank you so much. If anyone's here, congratulations. And finally, last but not least, in the first place, we also had, this was a very creative one and it was very, very well implemented. And again, great job. I think you can go places with this project, not just simply for a competition. So you already beat me to it and you displayed the screen. It's Nature Cool in first place. Thank you so much, Nature Cool, and congratulations. And yeah, if anyone's here and if you'd like to say anything about receiving the first place, thank you so much. We're happy to hear from you.
Thank you, ma'am, and all the judges. I really appreciate that you guys are really supporting us for almost all the events we have conducted so far. And yes, doing a project is like a very great experience. The amount of knowledge we gain by doing projects is something unmatchable. So I would like to appreciate all the faculties, especially Professor Sampath Suranjan and Professor Alvin and all my team, all my dear teammates who are actually working behind the scenes here right now. And I would like to appreciate all the people here for amazing opportunity we got. So thank you, ma'am. Thank you, sir.
Thank you, Sri. And it's our pleasure to be here again and in all your events, hopefully. And congratulations yet again. It was amazing to see your practical hands-on work. And I hope you go places with this dedication and this energy. It's very impressive. Thank you so much.
Thank you so much, ma'am.
Let's have a round of applause for all the dedication and effort that the participants have taken. A competition like this is the best shown in person, but during the COVID restriction, it is pretty impossible. We really appreciate all the participants who showcased immense interest and tried to convey their innovative concept despite all the restrictions. I would like to officially take this opportunity to place on record our hearty thanks to our Ashrae Falcon chapter and Mahe Dubai for the perfect logistic support and guidance they have extended to all of us for the ENERGIOMEX Project Competition 2021. We are grateful for all the support we got from our Dean and Chairperson, Dr. S.K. Pandey, Coordinator Mechanical Engineering, Dr. Rajiv Selvam, Ashrae Falcon Chapter Student Activities Professor Sampath Suranjan, and a special thanks to our beloved professors, Mr. Alvin and Mr. Ganesh, for their constant support for all the construction and for the in-campus projects displayed. We have been fortunate enough to be backed up by a team of very motivational and dedicated colleagues who know their job and are result-oriented. I would like to thank the chief guests, judges, participants, and the audience for taking their time to participate and attend this event. Thank you once again to all the chief guests, our beloved judges. I hope everyone has a wonderful and amazing day and stay safe.
Thank you, Nafisa. Thank you, everyone.
Thank you. Bye-bye.